knows. So this session is being recorded, and you should see the mark that we talk about. What we want to talk about first today is the transport protocols, and the transport protocols are at layer 4 as we go up, as we talk about in the OSI model. And the objectives are described, the functions of TCP and UDP. Those are the two protocols that operate there that we worry about. And identify well-known ports. And well-known ports are the ones that automatically go somewhere. The most well-known of well-known ports is probably port 80, which is where web pages appear. That means that when you type HTTP in, it automatically goes to port 80 on that particular IP address. And TCP and IP are frequently written together. That's because they work together, and there'll be a slide later on. But when you combine the IP address and the port number, you get what's known as a socket. A socket's where you actually get a connection, just like in an electrical socket you get a connection. But this one we get an information connection. And then they use netstat to identify open connection and services. It's a kind of I think kind of a handy thing to use on your own computer, because you can see what your computer is connected to, and if you come up with something really, really odd, you say, well, maybe something's going on this machine that I didn't know about. So the first thing I want to do is let's go back and look at what does the transport layer do, its major functions. The major functions of the transport layer in data networks: tracking individual conversations, segmenting data, reassembling segments. And what it's going to do is, and I'll show a Wireshark here in a few minutes, and there's so many things going on, I'll have to point out which ones go together. So many things going on this machine because I got more running on it than it really can support, but it seems to be doing okay. Reassemble the segments to put them together. And I think when we talked about the OSI model, I talked about being deployed and numbering my letters that I sent home so that you know if they came in sequence and out of sequence. And that's really what we're talking about here, is the data gets sent out. It may or may not arrive in the same order that it was sent, and that's what the numbering system is for, to put it back together. And that's only in TCP. And identifying the applications. The applications are where the port numbers are associated with. Like port 80 is associated with HTTP, a web server, so that it automatically gets that conversation gets associated with that application at the application layer. Controls the conversation, establishes a session, does reliable delivery, and reliable delivery only with the TCP protocol, the same order delivery and flow control. If we start sending data at too high a data rate, the other end can send a slow down message which says you're sending the information too quickly. That would be if somebody had a brand new machine and was sending it real fast to a really old machine, one that couldn't take the data at that rate. So we have those. Those are commonly called choke packets, which is to choke down the information. So TCP, connection oriented. In the little video that we talked about, he talked about reliable and unreliable communication. Those are terms that you will hear. Reliable means connection oriented and guaranteed delivery. Connection oriented means that we actually establish the connection before we start sending the data. That would be like a telephone conversation. A three-way handshake might be somebody calls somebody on the telephone, they say hello, hello, this is, and then you start the conversation. UDP, which is connectionless oriented, it does not establish the connection before you go. It's kind of like a first-class letter where you put the letter in the mail and you expect it to get there. And then it uses flow control and tear down. I've got another slide here, the SYN-ACK. What happens in initiate the connection is that we the workstation send a send packet to the server that says, I want to have a conversation. I want to connect to you. This is an incomplete connection. And what the send packet does is send the start of the numbering system, as well as I want to have a conversation. Here's the numbering system that I'm going to use. The SYN-ACK is actually the acknowledgement, and this is the ACKs are acknowledgement, and the SYN are synchronization. These go together, and then it sends its own synchronization packet. It says, here's my numbering system from the server, and then we acknowledge this. And just as an aside, one of the ways that denial of service attacks happen is the bad guy does this, the server does this, and then the bad guy doesn't do this. So the conversation's incomplete. If you get enough incomplete conversations, then the server can no longer accept connections because it has a relatively small buffer in order to establish the conversations. Before we get into that, they had the picture there. Let me drag mine over here. See if we can make some sense here. This is, I said there's a whole bunch of stuff going on my machine. I've got things running in the background. This one right here I think is doing an update. And we have, once we get the conversation going, we just have a whole bunch of ACKs. But what I'm looking for is a SYN, ACK, and an ACK, a three-way conversation. And you can, and I'm looking at this because these ones, where we go, SYN 353 215. Let me find the ones that go together. 2, 3, 3. These there. Here we go. Let me get this other marker over here to see if I can mark this. We send. Me sent a send packet with this number, and this is the way the numbers look. If you just start Wireshark up, it's going to have relative sequence numbers, which will start with 0. And this SYN goes down here to, let's find it, a SYN-ACK, to this ACK. And it gets incremented, and this is called the phantom byte. There's actually no data in here because our length is 0. But it gets incremented by 1. So we know that we're working here. And then this guy, the server, sends its own SYN number, and we find the acknowledgement down here for it. I said that this machine is a little bit hard to see because I got so many things on it, but it gets acknowledged, and then we have other sequence numbers as we go on, and the sequence numbers are added to based on how much data, the window size, we'll talk about window size, how much data can be sent before an acknowledgement has to happen. So a lot of things go on, and that's just the startup. Once we get going, we just send a bunch of acknowledgements, acknowledge receipt of this packet, send the next, whatever the next packet number is. That's the way it keeps track of these things. And then we talk about the well-known ports. We got port 80 here, and this is what we're synchronizing on. And then we'll talk about port numbers that we have. Port 80, the destination here, because it's going from my machine to the server machine, port 80 is going to be the destination port. This is going to be the port that my computer uses. And you can think about port numbers kind of like telephone numbers. If you're going to call me, you have to use my phone number. That would be calling the server with its port number. The number that you call from, it could be any of you, and that's what the port on our computer is the it's called an ephemeral port, but it can be any port number. So TCP to start up the three-way handshake, the SYN, the SYN-ACK, and what it's really doing is establishing acknowledging receipt of the packets and establishing a numbering system for the rest of the conversation so that we can be sure that everything gets to where it's supposed to be. This is what the TCP packet looks like, and we have the source port here, which is the port on our machine. So this would be, my machine is called an ephemeral, EPH, ephemeral, I think it's EPH. I wish that I had them. Ephemeral, which is temporary. I guess I could have just written temp, huh? A temporary. The destination port is the well-known. Port 80 for HTTP, and we'll look at some numbers here in a little bit. The ones that they usually like are 80, well-known, FTP 21, POP, Post Office Protocol 110, Mail Transfer Protocol 25, 443, which is Secure Web. And then we have the sequence number. We saw that in the packet, and the acknowledgement number. The sequence number is the ID number of the current segment, the sequence number of the last byte in the segment. The acknowledgement number is the sequence number of the next segment expected. What they're saying is, acknowledge receipt. What the acknowledgement does, I got 6, send 12, or send the next one. What you're doing is acknowledging how much you got. And the reason that happens is so that TCP, if you don't get the entire package, then it will send you a redo. It'll do it over. It'll send you the system again. I know I'm stumbling here because I'm trying to get the rest of the, well, we'll do it in a second, the rest of the attendance done. The length of the data length is the length of this TCP segment. We have a reserve section in the flags. The flags are used to do the type of content. Now let me go back here. Let's go down here and look at, down here at the bottom, look at the TCP, and the flags in TCP are reserved, is not set. Nonce is a number used once, and that's used in security. Congestion window, we talked about being able to report that we have congestion, that what's going on, and it can be set here. An urgent packet, and it's not set, and these all not set are because of zeros here. Push packet, what these conversations normally do is wait until a buffer gets full and then sends the whole thing at the same time. A push packet sends the data whether the buffer is full or not. Reset, and a reset is basically a hang up. Let me go up here, and we should be able to find some resets. We got I got some duplicate acknowledgments up here. One of the things that Wireshark will do for you is change the color for things as they get bad. I knew there was some. I bet you there was a reset in here. Maybe this conversation was better than I thought. We're getting a lot of duplicate acknowledgments in it though. Anyhow, if we get a reset's basically a hang up. It just stops that particular conversation, and it's going to show up as red in this thing. And then the send, which is what this packet was, the start of the conversation, would do that. Starts the conversation. It's got the 1, and it's the flag that's set. And then when we get ready to end the conversation, we go through the finish, and it goes through a FIN-ACK, a FIN and acknowledgement, and then it's a 4-way handshake. Each of them sends a finish segment. So we have a number of flags in here. The window is the amount of data the host is willing to receive before sending another acknowledgement. How much data can we send at once? One of the things that slows down wireless until we got to the 802.11n standard was this, in that wireless required each packet to be acknowledged, and instead of being able to acknowledge a whole bunch of packets, it's kind of like that if you took the you're going on a field trip with a bunch of kids and you had a school bus, and think about each of the individual students as a data packet getting on the school bus would be the window. We would acknowledge that all of those students in that bus got there instead of trying to do it one at a time, taking the attendance one at a time, because we already took the attendance once when we did that. The checksum ensures the validity of that particular packet. So it's one of the things that we would use to ensure that the data had not been disturbed as it went across the network. The urgent pointer, if it's set, it specifies the end of the data in the segment when we do that. And we have a number of options, and they may or may not be used. And after that, the options, further connection parameters to be configured. The most important, one of the ones that would be there, is segment size. Trying to find my thing, options here. And then after that, we have the data. And if you think back to the OSI model, the transport layer is, as we go up, we have the transport layer here, and then in the TCP model, we have all the application up here, because those things are kind of all related. So we have the data connected after we do that. This is one of the again, the three-way handshake. Well, this is closing a TCP connection. Receive a close, we send a FIN, or somebody, one of them sends a FIN. A FIN, I keep forgetting to take the pen with me, don't I? A FIN receives the FIN, and then it acknowledges the FIN. Then the server sends a FIN so that each of us knows that the conversation is actually finished when we do those things. So close, and after the last acknowledgement, it's going to do these things. Then we close the connection, an orderly closure of the connection, not just a hang up. We click turn the server off, or turn the browser off before we actually get to some place that we were supposed to do. UDP, connectionless, non-guaranteed delivery, and you can see it's a whole lot simpler than the TCP. We have the source port, the destination port, where we're coming from, going to, the length, the checksum, and then the data. So it's a lot more efficient. It's normally used for streaming, things like that. This doesn't mean that nobody or nothing looks at what's going on. Usually the reliability in UDP is done at the application. So it does kind of pay attention. And this one is talking about something else, does the acknowledgement. If we did the first class letter and you sent it to somebody, you put a check in the first class letter and sent it away to whoever you were sending the check to, you don't really know that it got delivered unless they called you and said, hey, I got you a check, or you call them, did you get the check? So something else checks the reliability of UDP. The well-known ports, and I think this is in the book, well-known application ports, and they are port numbers 0 through 123, and the transport layer has port numbers. TCP and UDP, they're separate. And if we do the port number plus the IP address, we get a connection, and the socket, and the socket's where the connection is. Over here we have these, usually 21's considered FTP. That's the one that starts the FTP connection. Telnet 23, I've seen that one on. 25 is simple mail transfer protocol. That's the one that sends mail. When we did the mail, we have one protocol to send it and a different protocol to get it. 53, and you notice that 53 uses both TCP and UDP in its domain name system. It's the thing that looks up the name, the IP address of the names when we type in www.leaderquest.net. The DNS server tells the computer what the IP address is so that it can go to that system. And then we already looked at these two with DHCP 60, 67, and 68. And in Wireshark, if you want to find these things, it's going to be boot P. They haven't actually changed that thing. Trivial file 69, web, post office protocol, the old protocol for email is 110. It is used, it was designed for dial-up really, so that you could go to the server, the email server, get your email downloaded, and then not have to try to worry about it online. The other post office protocol is IMAP, Internet Mail Access Protocol. It stays connected to the server. That's what we use in most cases today. Network administrators do not want to use this one because you're required to do mail backups typically. And if you use 110, you can configure the client to download the mail and delete it from the server. 143 is actually just a connection to the email server. 443 is secure HTTP messaging. 3389, if you run remote desktop, you have port 3389. The reason that these ports are significant, if you have firewalls, you have to open up these ports to allow connections so that we can get through the firewall, because the firewall by default is the one that is the thing that just doesn't allow anything in or out of the network. NetStat is a handy little thing. It shows the number here. Let me bring one up here, maybe, if I can do a command prompt. Properties. If I go over here and just type NetStat, if I could type, it tells me, and this is going to be a long list of what's connecting. We have the local address, the foreign address, whatever the other guy is, and then what's the state of the connection. And these are established. These are things that are running on. I think most of these are the Servio server that are running here. And then it goes on and on and on. Closed, and it's waiting. Closed and waiting on these. If you're ever curious about what's connected to your computer, you can do that. And then if you want to know, let me close this, netstat / will tell you what all the switches are. If we wanted to know, one up here is what executable is doing this, so that we can go either shut it down or find out what's starting it and make it not run, or go into msconfig or something like that and not start it. That wasn't what I wanted. B, didn't I? B and E, this sounded like. Oh, requires elevation, which means I've got to run it as an administrator. And I think I can do that. Maybe I can do that. A bigger version of it. So -B. So this tells me, it says a plugin. Here we go. Servio over here. The Servio service has got most of these plugins. 127.0.0.1 localhost. That's me, obviously. The computer address is 168.100.150, and global HTTPS. It's been on. These are closed and outs, waiting to see if I want to reopen those things, and this will go on for a long time. Dropbox is running on this machine. A number of things happen there. This is one that has, like, I don't know how you get anything that only has 2 connections, but I guess that theoretically it's possible. So the review, What we wanted to do was describe the functions of TCP and UDP, identify the well-known ports, and use NetStat. Hopefully we've done at least some of that. Did we do that? What is the purpose of TCP and UDP? Do I have to start over?
Reliable and unreliable.
Reliable. It does the conversation, keeps track of the conversation. And I think it's a little bit confusing between this and session, because we talk about the session initiates the total connection. What this one does is initiates the individual conversations. So the questions: why would a developer choose to use unreliable delivery over reliable connection-oriented delivery? Sorry about
time
that.
sensitive.
Huh?
Time sensitive data.
Yeah, well, time sensitive data, exactly, when speed's more important than reliability. Depends on what you do. And when you get into things like telephones and the telephone packets, and they use their own protocol, but reliability of those, if you lose a packet or two, it's really not that big of a deal because they're very, very small packets. And these things like we're using, the virtual meetings, use some pretty small ones also. What's the purpose of the window field of the TCP segment?
It's the amount of data the host is willing to receive.
Exactly.
Between acts.
So it's how much, what they do is a negotiation, and they decide on how much data can come at one time. And then what TCP actually does, more than you ever wanted to know, is it tries to increase that amount of data, and it steps it up, steps it up, steps it up. It's called the TCP sawtooth, because it becomes a sawtooth wave. And when you get too much, the other one says, too much. So it drops back 50% of whatever the data rate is and starts building up again to try to maximize how much data can be sent in one chunk. So the window size would be like how big the school bus is, whether it's a 60 passenger or a 30 passenger or whatever, how much data can go into it. If the client is in time wait state, is the connection with the server still open?
I would say yes.
Well, that's one. The answer is maybe, but probably not. The server closes the connection when it receives the ACK from the client. This packet lost, the server connectivity may still be open. So that one's maybe, but probably not. Normally no, but it could be if that one got lost. What are the sizes of the TCP and UDP headers? And I know we didn't talk about that. I didn't say what the sizes were. But anybody got an idea?
On the bottom of one of our pages, it's 8 and 20. 20 for the TCP and 8 for the
Yep. TCP header is 20 bytes and the UDP header is 8 bytes. And if we go back and look at those things, these are 32-bit, 1, 2, 3, 4, 5. Anyhow, and then the UDP, much smaller, 1, 2, 3, 4, 5, 6, 7, 8, because eight of these. So what we got here is what, 1, 2, 4, 1, 2, 3, 4, 5 times 4, 20 bytes. 8 bits is a byte, right? So we have 8 bits here, so we have 4 bytes on each of these lines, 5 lines, 20 bytes. A function of TCP is to handle flow control. What's the purpose of the flow control function?
Let's see.
Huh? What's the purpose of the flow control function?
Stop the host from being inundated with data.
Too much data. I remember years ago, and this was years ago, in California, they had red lights to let you or not let you on some of the interstates so that they controlled the amount of traffic on the interstate at the point of entry.
They still got it.
They still got it?
Yeah.
Yeah. Last time I drove on one of those was in like 1977, so you can tell how long it's been since I've seen things like that. But I guess that the flow control of TCP is sort of like that. Instead of flow, and what I always visualize with TCP packets or data packets is something like that. An interstate highway, duplex is an interstate highway, simplex is a one-lane bridge. The data packets are the cars moving back and forth, and when we want to do flow control, we can slow down the amount of data that goes back and forth. And if we have the size of the packets, like the school bus we talked about, and think about the kids being, I know that kids aren't data packets, but the kids would be data packets. They have stuff in their pockets and stuff in their brains, but how big is the school bus? How big is the window size? True or false, user datagram protocol, UDP, like TCP, uses flow control in sending of data packets. Do you see anything in here where in the packet where it would have anything like a flow control? Okay, somebody tell me the answer now.
False.
False. Which ports are closely associated with web applications? Go back to 80 and 443, HTTPS or HTTP secure. Both of those are going to be that. If you wanted to investigate the connections on your machine, which utility would you use?
That was a long time ago.
Netstat. And it's got a number of switches. I think it's worthwhile to know how to use on your own machine and run it every once in a while just to see what's going on, what's connected to you. For the next about 40 minutes, that's what he's got on the schedule, let's work on Lab 10. And at the end of the day, I think there'll be extra lab time that you can that we can do. We end the day with a lab, and then I don't think that it would go to the scheduled end of day, but we'll see. Again, what we're going to do is try to get 2 hours in before we take the 2-hour lunch lab combination break, because Dallas and you guys in Dallas have to get out and get back in, get your lunch and get back in before noon, because as I understand it, they lock the building at noon. You can get out, but you can't get in. The objectives here are describe the format of host names and fully qualified domain names. And the host names, the format of host names are like whatever your computer name is, computer 1. Understand the process of name resolution using DNS, using hosts and DNS. Identify the basic configuration parameters for a DNS server. The DNS server is a thing that does the resolution. It takes the names, that we don't like numbers, takes the names that we type in and makes them IP addresses. So the routers can find the network, and then layer 2 can find the specific machine. Use NSLOOKUP and NBTStat to verify and troubleshoot name resolution. NSLOOKUP is a utility that allows you to test DNS. And NBTstat allows you to test the host file, what's called the host file. And I want to look at one of those in a minute, and then we'll also look at a couple of things in DNS. So the host names, letters, numbers, and hyphens, can't be all numbers, can't start and end with a hyphen, and is not case sensitive. The host name is the name of the computer. Whatever you name the computer is what the host name is going to be. A fully qualified domain name is the host name plus the domain suffix. If you're in an Active Directory domain, let's go leaderquest.net, then the fully qualified domain name would be computer1.leaderquest.net. The host name's got to be unique within the domain, because once we start working on these things, if they're duplicates, then we have the collisions again. We're not allowed to have duplicates, just like we have duplicate IP addresses, although generally this one's not as severe as the IPv6. It'll tell you a duplicate host name, but generally won't let the second one online. The labels separated by periods. The domain was leaderquest.net. The host name was computer1, so separated by periods, host or computer1.leaderquest.net. And just like when you go to a domain on the internet, www represents a computer out there. .esaa.com would be the fully qualified domain name. And the internet addresses don't have to be the same as the host names. If we go to a website, we can make it whatever we want it to be to go to the port 80, the well-known port for web servers on that computer, because it's a separate function. And that's going to be the address that's listed in DNS. DNS is the thing that's going to get us to where we want to be. The maximum length, and this is the maximum length for the fully qualified domain name, is 253 overall characters, 63 characters per label, excluding the period. So we can have, and that's probably not a good idea, because this is me. I like to make things easy to type. I don't like underscores. I don't like dashes, although you can have them. Don't use spaces, because the space will normally insert an underscore, or if on the internet it's an ampersand or ampersand or something like that. Thing called camel case, where you capitalize the start of each word and the lowercase for the other stuff so that it's easily read, but that's a personal opinion. I just don't like those things. I used to work with a guy that loved to use underscores, and they're just hard to type for me. Think of when you do those things, think about what the user is going to have to type. Hosts is a text file. It says was a text file. It still is a text file. It contains a list of IP addresses or fully qualified domain mappings, and they're distributed manually between network administrators. DNS has long replaced them, but you still have one. I still have one. We have them on a Windows machine, and I'm going to drag this over here. This is the directory structure. It's in the Windows, Windows System 32 drivers. Etsy has a number of files in it. One of them is the host file. This has got a host file and a backup. I want to show you the difference between these two, if I can get them up here. Let me do the original first. This is my original host file, and it just gives some examples, and the only thing it really has is 127.0.0.1. This one here with the pound sign comments things out. I was having some resolution issues with this website. I help them with it, and I put this in the host file in order to be able to get there to see if it was working or if DNS was the issue. As it wound up, it was DNS. But we can do these things. But it gives you some examples up here of how you would make entries into this thing. When you start the computer up, the host file automatically gets loaded into the cache on the machine. what my current host file looks like is this one, because Spybot came in and I inoculated my computer, and it took its thousands of bad guy addresses and told them to go to 127.0.0.1 instead of going out on the internet. So it resolves all of those things to my local computer, which doesn't have any of that stuff on it, any of those websites on it. So it just diverts everything there. When you start up your computer, the host file is loaded into the cache. And if you want to see what's cached, and I did a run on this one that goes on and on and on and on, because all of those bad guy things are loaded in here, and they resolve to my local computer 127.0.0.1 where we want to go. There are some other, what I want you to see, there are some other documents in the Windows System 32 drivers etc. One is the list of protocols that I can open hopefully with Notepad, and you should open all of these things with Notepad because they are text files. They don't have a TXT extension, but they are text files. This gives you the protocol name, the protocol number, the alias, IP is IP. We go down here, we talked about the other day. TCP is protocol number 6, TCP, and then a comment about it. So that one's there. The other one, services, if you want a list of, well-known ports, that's what the services are. These are the services that are running on your computer. So the list goes on for a pretty long distance. Those things are all there. But the host file, way back when there were 2 computers in the world, it was easy. Instead of using an IP address, you wanted to use a name. You put the computer name and the IP address in the host file. When we get millions of computers, host files are impractical. And that's where DNS come in. But you can configure static mappings, and they're going to load first. When the computer tries to resolve a name to an IP address, the first place it looks is in the DNS cache. And you can see that with the ipconfig /display DNS. It's one of the switches. It'll tell you what's there. And every time you go to a website, it puts that in there so that it can get it quickly without going off of the computer to do a lookup. The next thing, the next thing we say, it looks in the host file. It actually is going to look in the host file because the host file is loaded into that cache when the computer is started. So it's something that can help you or can hurt you. And in the case of Spybot there, it helps me because any of those things that I don't want to go to or get myself infected, it just looks on my local computer and it's not there, so it gives up. It'll time out. The DNS system is hierarchical, and we got a couple of what's called top-level domains here. The process that this thing goes through, and we got 2 different kinds of lookups. One's called an iterative lookup, and one's called a recursive lookup. And I think those are talked about in your book. Let me see if I can find them here. I know it is. But when we look at those things, it's what answer, how far the system is going to go, or what process is going to go through to give you the answer, to give your computer the answer. And DNS uses 2 protocols. It's port 53, but it uses TCP and UDP. Port 53. I'll have to find that iterative and recursive. But anyhow, when we do these things, and they've got the system in there, if you want to go to some place and it's not listed, you'll go to your DNS server. DNS server doesn't have it. If it's an iterative lookup, it'll give you the best answer that it's got. If it's not, if we do a recursive, first it'll go up to the root, which is represented by a dot, and ask for www.leaderquest.net. I don't know, but I know where, I will say that LeaderQuest is leaderquest.com, but I know where the com is, so it'll send you back the address of the DNS server for the com domain. You go to the com domain and it'll give you the address for the DNS server for LeaderQuest. You then go to, and we'll pretend this is LeaderQuest, to the LeaderQuest DNS server, and it gives you the IP address of the www. You can go through, you can see that it is going to be much faster if you can just do the lookup on your own machine. I put a link in here for the root server locations. You've been told that you can bring down the internet by taking down 13 name servers, and the name servers are the ones that are listed there. And let me bring this map over. This is, yes, there are 13 of them, but oh golly, now I made a mess out of it. This is a map of, going the wrong direction with the mouse. This is a map of where the quote 13 DNS servers are. And I made, there we go. They're all over the world. And this gives you, if you click on it, it'll show you where these things are. The letters represent the companies that actually run those particular servers. And if you want to look at it, poke around at it, it's root-servers.org. Be careful because they've got some porn sites that have some really close addresses to it. This is their representation, and this is the one they have. They have the text in the book that walks through that, through the how the lookup works. So you can look at that. This one we go to our DNS server. It doesn't have the answer. It goes through all of the 1, 2. Let's see if we can. Let's see if I can mess this up. Go to our DNS. We go to our DNS server. We're trying to get to widget.com here. 1 goes to 2 here. DNS server doesn't have it. 3 goes to the top level domain, sends back the IP address of the .com DNS server, top level domain server. Go to .com and it tells us what the IP address is of the widget DNS server. We go to the widget DNS server and it tells us the IP address of www, and then we can get there. Kind of a, I guess maybe seems convoluted, but it works, and this is a system that's worked pretty well over the years. And once you go to www.widget.com, it's going to be cached on your local machine in memory there, and will stay there until you either flush it or turn the computer off. These don't really time out. Service ports, UDP, port 53. We have two different ways, two different things that can happen in DNS. The UDP port is used for the name lookups. What's the address of www.yahoo.com? TCP port 53 is used to transfer the database, and this is called a zone transfer, because we have different zones in this thing. We're called primary, secondary, and cache only. A primary is one where we can change, we can put in the IP addresses and the names of the computers. A secondary is a read-only copy that we get with a zone transfer. When we do a zone transfer using TCP port 53, it becomes a secondary on a different DNS server. It's therefore to speed up lookups so that we can do those. And the caching only server goes and does the lookup and then caches whatever addresses that you've gotten in that server. What it does, again, it makes lookups quicker, and it's based on what users have done in the past. And now we get to the iterative and recursive. In these things, the name servers can be configured to provide forwarding, and most queries between name servers are iterative. A server responds to a query with whatever information it has. A recursive means that if it's queried and it's not authoritative, authoritative means it's the one that I can make changes to. It does take on the task, and it refers to the other name servers. That's when it goes to the root and into the top level and into whatever that particular domain is, and gives you eventually the name of the server. The records, the resource records that are in DNS, we have the start of authority identifies the name server that is authoritative. And again, what authoritative really means is we own that domain. We can make changes to that domain. Nobody else can. If somebody else has our domain listed on their server, it's going to be a secondary. It'll be a read-only copy of it. Two different addresses for IP addresses mapped to names, and these will be fully qualified domain names. The A record is for IPv4, and the AAA record is for IPv6. And IPv6 is on the Internet Root DNS server, so you can get IPv6 addresses for the systems that have them. An NS is a name server. It's where you would go to look up the address of something. If we were looking for www.leaderquest.net, we would have to go to the name server for the domain leaderquest.net, and it might be like nameserver.leaderquest.net, and that's the thing. It would be listed at the .net server. It identifies the authoritative name server for the zone. A pointer record is an IP address mapped to a host name. It's a reverse mapping where you can find the name using the IP address. Can be handy sometimes, not used in some cases. A canonical name is an alias. If you wanted to do like a store and you were mydomain.com and the store was someplace else, a C record would be one that you would put in DNS, that when you went to store.myname.com, it would go to a different location, maybe free web store or one of the other places that you could have a web store with. The MX is the mail exchanger record, and when you have mail records, you have two of them. One is the MX record that says this is where the mail server is, and the other one is an A record, how you actually get to it. An SRV or service records, these are normally used in Active Directory, and they are used to identify services like Active Directory or a registration server or something like that. But those are the name records. I think the big ones here are going to be, well, maybe A and AAA are going to be for individual resources. NS kind of easy because NS stands for name server. CNAME is an alias, which I never found a good one for. SRV is service records, and then MX is mail exchanger, if we want to do those things. Dynamic DNS allows the clients to notify the DNS server of IP address changes or IP addresses. This was one of the real advantages of Active Directory when it came about in Windows 2000. When a machine in an Active Directory domain starts up, it gets an IP address from the DHCP server. It can then report its name and IP address to the DNS server so that we can resolve it without having to know the IP address or make a change to a host file or anything like that. Two ways to do it. The hosts can report the addresses for themselves, or you can configure the system so that the DNS or the DHCP server communicates with the DNS server and gives it the addresses. Update to the DNS server records may be requested by the host. The other thing that can be used if you don't have a permanent IP address assigned by your ISP, which most of us don't. We talked about DHCP. Remember, it renews and most of them are DHCP addresses. It renews it at 50% of the lease time, and they tend to stay the same. But if they change, you can subscribe to a dynamic DNS service, and it will automatically update the records in DNS on the internet so that you can get to your machine using a name instead of an IP address. So internet DNS can be used on our small office, home office machines, and if you use the DMZ portion of it, you can, and then usually it says a web server, you can put a web server there and use that name. The thing that I found is that most of the ISPs actually block port 80, so it makes it difficult to use. You have to use a different port number in order to do that. NS lookup is a thing, a device, a utility that will let us test DNS. I'm trying to open this thing here. Try to make this a little bigger. So if we do NS lookup, we can find this says it's the address unknown. This is going to be the DNS server that does it. It tells me the address of www.ecpi.edu and tells me that we can find that. If I did, let me get out of here. If I did NS look up, and 8.8.8.8 is a name server. The address of the name server, this is a public Google name server if you ever want to use it. It's still non-authoritative. Non-authoritative means I don't own it. I can't make changes to it, but we get its address. I'll go to do one other thing, a set type equal MX. If we wanted to look up the mail records, google.com, these are the addresses, the mail exchanger for Gmail. So it's got that number of servers working on it. What this does is tests DNS basically. The other one, NBTstat, gonna give us some statistics. This is the help file. They're gonna give us some net BIOS statistics about the machine. So if we want to look at resolve names, for instance, in this, I don't think this one has any. We don't have any. Let's see. It's not going to be a whole lot. Not going to be a whole lot because this machine doesn't use a whole lot of NetBIOS. But virtualize. This is the name of the computer, and this is the NetBIOS code. Type is unique. It's registered with itself because it's the only one on the network. It's a work group. It's not in a domain. Work group. MS Browser is a Microsoft thing, a Microsoft browser. It has to be everything because it's the only one on the network, the only Windows machine running on the network. Interactive mode, when we go into NS lookup, the interactive mode, it should have. It's got a bunch of help screens too, which may or may not make a whole lot of sense. Actually, they do. What always got me when I wanted to change type was the set type, and you can't use a space between the type equal and then whatever the record is going to be. If you just type NS lookup, it's going to tell me what my address is. Lookup. Actually, I don't want to do that. I'm already in NS lookup. I can tell that by the command prompt. If I type help, it's going to tell me all of the switches that I have for the system. You're probably not going to be, if somebody's done a poor job setting up their DNS server, you should be able to dump their whole domain, which is not a good thing in order to do that. The NetBIOS over TCP supports legacy clients. You can turn that off if you want to in the NIC properties. NetBIOS may or may not be necessary on your local network. It's probably not necessary. The only thing that it really needs to be used for lately, I think, is some applications that still run on networks have to use or still use NetBIOS and use the NetBIOS lookups. It uses UD port 137, TC port 139, or TC port 445. Use the query name information, and this is the one that we were looking at on my machine. So the format of the host names, and those are the objectives. Understand the process for a lookup of hosts and DNS. The host is right there. Identify the basic configuration of a DNS server. Use NSLookup. And one of the labs you're going to do during the break that we're going to take here is going to be the DNS. So let's do the questions, and then we'll take our 2-hour lab lunch. What is the generic top-level domain?
Is it TLD?
TLD, yep. Top-level domain. Remember this, the FQDNs are arranged in a hierarchy starting from the root, which is represented by a dot, and the top-level domains are and they keep adding to them, the netcom, edu, mil, on and on and on and on and on, the places that you can get them, and underneath that are going to be the individual domains like Microsoft and Yahoo and those things, and you go to their DNS server, and they're the ones that list the IP addresses within their own domain. What characters are allowed in the DNS host name?
Any text? No.
Any tab? Well, it says up to, and the answer they gave me is not to the question. So it's anything we can use. We can use a hyphen, but you can't start or end it with a hyphen.
Or all numbers.
All numbers, exactly. You can have up to 63 alphanumerics and a hyphen. The hyphens, in rare instances, can cause issues with some DNS servers because it can truncate it and you won't get the full lookup. So again, this is just me, but I don't like those special characters because they're too hard for me to find with my little finger. I don't like the dashes and I don't like the underscores, so I use camel case, just a personal preference. What is the location of the host file in the Windows?
Windows /system32/
drivers etc.
drivers/etc.
Yeah. What type of DNS record? What's the symbol? What kind of DNS record resolves IPv6 addresses?
AAA.
Yeah, triple or quadruple A. And then what resolves IPv4 addresses then?
A.
A. Just single A. What type of DNS server is likely to accept recursive queries? Remember, the recursive is the one that gives you the answer, whatever it knows about. And if it has to go out and find stuff, it's usually going to be an iterative server. And I know I answered that question, but a local name server is the most likely to give the recursive query. What's the use of a pointer record or PTR record in DNS? And I don't know where they came up with these names. An A record goes from name to IP address, right?
Reverse, I think it's
Reverse,
something like
yep. It goes from IP address to name. What types of DNS records have priority or preference values? Yeah. And I didn't cover this, so I'm going to answer it for you. Typically, that's going to be an MX record or an SRV record or service record. What type of DNS enables clients to report a change in IP address to a DNS server? You tell the server what your IP address is.
Oh, SOA.
oh yeah, exactly. SOA.
What about this one right here? Dynamic DNS. SOA is the start of authority. That's the declaration of where we're going to start, that we're the authoritative server. When you go through the DNS lab, I think they're going to have you look at the records, and hopefully it's going to make more sense after you do the labs, because and it goes back to what Tamika told me earlier and what Timothy was saying. Look at them, read the books. Hopefully I'm helping a little bit, and then see what's in the thing itself. And I agree with everybody said that the labs, unless you do the labs, the memorizing doesn't do a whole lot to show you how it works. But you can, in many cases, I won't say in all cases, I haven't looked on my new router, but my old router, the Netgear router gave me the ability to go into the router and say, yes, I want to subscribe to your dynamic DNS service. Now you had to use their extensions, their domain name. But I could then get to my location by using a name instead of an IP address. Probably not as big a deal now because of the, and I'm going to call them persistent addresses that we get from our ISPs, but those are there. I'm going to have to go quickly now because I'm taking too much time and Dallas not going to be able to get back. What is the function of the command nslookup 8.8.8.8?
Google.
We're going to start nslookup and use the DNS server 8.8, which is a Google DNS server. What you're doing is telling it to start, and this is the DNS server that you're going to use. Otherwise, it will use the one that is in your IP configuration. To view the cache NetBIOS name entries, and you can look at the NBT stat help for that one. I want to get through this so that you guys can go get lunch and get back before you get locked out. So it's NBT stat-C. So in order to conform to everybody being able to get back, what I want to do now is, and depending on what time zone you're in, what order you want to do things, do the labs, lab 11 and 12, and take the hour lunch break that were allotted. Okay? Okay, I did start the recording. So on this unit section, what we want to look at is troubleshooting. And when they ask you questions on the CompTIA tests in general, they want you to answer based upon their troubleshooting model, which it's a good model. It may or may not work for the way you troubleshoot, but it is. So it's use effective troubleshooting procedures following the CompTIA troubleshooting model, and they will ask they like to ask troubleshooting questions, or at least they have in the recent past. Troubleshoot common connectivity scenarios. Troubleshoot problems in the networking infrastructure. Troubleshoot problems with network services such as DHCP and DNS. And all these things may happen to you. I mean, over the course of years, probably the infrastructure is one of the things that really does. And what we found in our particular network was that a lot of them were at layer 1. And what you got to do is decide, and one of the slides is going to say top to bottom or bottom to top, however you choose make it work, and then which tools work for you, which tools are going to reflect what's really happening in your network. So purpose of troubleshooting, I want to get, if we can get a little interactivity here, and I want to pick on Tamika, and I think she's back because she does help desk, which is a troubleshooting area. And are you there, Tamika?
I am.
Tell us a little bit about what, I know you said you're getting bored with it, but you do troubleshooting there, don't you?
Yes, sir. I do password resets, different types of things, installing and uninstalling software.
Yeah.
Have different type of permissions you have to go through, stuff like that.
Yeah, and when people call you up and said, doesn't work.
Yeah.
Something doesn't work. Well, what happened? All I did was turn the computer on. They never have installed anything themselves. They've never gone to a website that they could get infected with. They've never tried to put a piece of hardware on. They just turned the computer on and it didn't work.
That's what they always tell me.
That's right. And that's the kind of thing. And then you've got to figure out a way around that, don't you?
Yes, sir. You have to overanalyze it, if not underanalyze it.
Yeah. Yeah. And do all that while not insulting the user.
Exactly.
I mean, it's not an undifficult job. It is a difficult job. A lot, not all, but a number of IT people starting in the IT world start out on help desk. She's already done her time there. But I've had a lot of students, some of them went into small networks who immediately became network administrators, and they've done very well there. A number of them went to big organizations and started out on help desk. But the purpose of troubleshooting is to fix the problem. Like she said, people call up, they've got an issue with this, an issue with that, this isn't working, that isn't working, something else isn't working. What we're talking about in networking on a larger scale is probably not going to be the individual application on a desktop, but the network itself. All of a sudden, people can't get to the internet. For what reason? All of a sudden, you can't get to a server. For what reason? So how are we going to do those things? What's going to work? How are you going to keep the network up? Because we've talked about things, and one of the things we talked about in the switching was spanning tree, which prevented loops, and did a little demo, and hopefully it made some sense after a while that when you get a loop at layer 2, it just keeps going, because unlike layer 3 in IP, which has a time to live, has a hop count, and the packet will eventually die, there's nothing like that at layer 2. It just goes on forever, and as a matter of fact, it builds to get bigger and bigger and bigger because you get more and more and more broadcasts, and those are all caused by broadcast storms. So the purpose of troubleshooting is we want to be able to make the network work again. And to do that, they talk about problem management, but the CompTIA networking model is: 1, identify the problem, establish a theory of probable cause. Now, you're going to have to probably do some things in the interim to establish the theory, do some what's going on here, what's going on there. The real advantage to me about starting at layer 1 is you get a lot of help. You get a lot of visual cues when you look at a NIC as it plugged in. Is the link light on? When you look at a switch, are the lights all flashing at the same time? Not a good thing. Have we created a loop? When you look at a switch, are the individual port lights on for the link light? That's going to give us a pretty good indication that we're working at layer 1, and then we can work our way on up there. Establish a theory, test the theory to determine the cause, establish a plan of action to resolve the problem and identify potential effects, implement the solution, or escalate as necessary. You may have to escalate. There's a number of reasons to escalate, and there's a slide on that later on also. But the biggest one is you don't want to void the warranties, because if you do that and there's something that was wrong, then they're not going to replace it for you. Verify full system functionality, and if applicable, implement preventive measures. And I don't know, sometimes when I was doing it, you'd fix something, work, and about the time you walked away from the desk, something else would break. But those things are going to happen to you. One of the big things that many of us in this world are not all that good at is the last one here, document the finding, actions, and outcome. The reason that is significant is probably going to happen again. What did you have to do? What steps did you take in order to do that? That's particularly helpful in a large organization. I should do that at home, but I don't. But I'll go change something, and it's okay, it's okay, it's okay, and then 2 weeks later my wife said that this doesn't work. Did you do something? No, I didn't do anything yesterday. And then I'll sit down, and all of a sudden it'll come back to me, well, 2 weeks ago I did this. And that's what caused that. So there is a cause and effect on much of this stuff. I won't say all of it, but much of it. Sometimes the system just doesn't always load correctly. So identify the problem, and we have two different sets of bullets here, but the ones out of the book are gather information, duplicate the problem if possible. The real difficult things to troubleshoot are the ones that are inconsistent. If it does something one time and then something else the next time, those become tougher and tougher and tougher. And like Tamika said, question the users. What did you see? Not what'd you do to the computer? What'd you do to the machine? Unless you've got a really good relationship with them. But what do you see on the screen? When you restart the computer, what happens? When you start this, what happens? What used to happen? What did you see before? Do those things all make sense, Tamika?
It makes very much sense. That's what I deal with on a daily basis.
Yep. And it's really difficult to do to imagine. I mean, I personally, I don't think I'd be a very good help desk person, but sometimes
I remote in on their system, and through there I can see exactly where they actually went or whatnot.
Yeah. What software do you guys use for that?
I use basically semantic encryptions. We got different various softwares that we do use. One is semantic encryption, though.
Yeah. Yeah, and that is a real advantage. There are a number of softwares that you can get that allows you to connect to the user's desktop, so they don't have to describe what's going on. You can see what's going on, and then you can go in and look at the configurations. And I think that's probably very helpful. I said to Mika, I need your help in this one. This one works out really good that you do this, because it's not an easy thing to do. And then the next one, determine if anything has changed. Like I said, I changed something, and when did it change? It doesn't have to have changed in the last hour. It may not show up for weeks. In routers, sometimes it may not show up for years because you don't reboot a router very often, and some changes that you make really don't take effect until you restart the router. And you restart the router, and all of a sudden the world changed. And sometimes you don't save stuff, and it knows that you can make changes and it runs in memory. If you don't save the configuration file when you restart it, then nothing that you did has been saved. So those kinds of things, what happened to it, determine if anything's changed. Approach multiple problems individually. If there are multiple problems on a machine, approach them individually. And one of the things, do one thing at a time. Mm-hmm. Because if you do multiple things, then you know what fixed it. Something's wrong with the machine. You change 4 different things, and all of a sudden it's working. Now, which 3 do you need to go back to? Is that the reason why I'm still going to pick on Tamika, because I saw her start to say something?
No, you're correct. You have to fix one thing at a time, because like you just stated, if you start fixing on different things, you have to explain to your boss or whomever you have, I guess, advised to, what did you do to fix the problem? And if you don't give them a direct answer on what you did, because they have to give that to the group, and then that's how they'll be able to fix the issue the next time it comes around, and whatnot.
Or if you have to move it up to the next level, what have you done? They need to know that. And the open questions are describe what happened. You don't want to use closed questions or the yes/no questions, because that does put thoughts into the minds of the user that, yeah, this is what they want, or this is what I saw, or this is what I didn't see. Logs and change documentation, they start here. Logs are very handy to look at to see what's going on. And me not being the very logical person, one of the last places that I typically look is the logs, and one of the first places that you should look is the logs, because it'll tell you what's not working in many cases. Change documentation means that you actually record changes when you install something, make modifications to any of the hardware, any of the hardware configurations, change drivers. You need to document that. And you need a change process when people request that things happen. The last place I worked, we had IT and medical. And the medical instructors had convinced the network manager that they really needed to be administrators on their computers so that they could try out these different things and watch videos and try different softwares and things like that. And what it really wound up was that they got their machines pretty well infected. They did these toolbars, shopping toolbars, and all sorts of stuff all over their machines. So you need to, in the logs and the change documentation, and control what users can do with their desktops. We can do everything with our ones at home, but you don't want users to be able to do a whole lot to them, because if they can make changes, that's just going to make your job more difficult. And then if there are multiple problems, are the problems related? If not, do one problem per ticket. And that's all part of the determination. And a lot of this is, as you do this for a while, she says she's been doing it for 7 years, so she's getting pretty experienced at it. Establish a theory from the known symptoms. And this is going to be based on what you see and are told. And in the book they say, establish a theory, question the obvious, consider multiple approaches, top to bottom or bottom to top of the OSI model, and then the divide and conquer thing. What is going on? What are the obvious symptoms? And one of the things way back years ago, NetWare had a troubleshooting test that you could take. I took some really dumb tests. And one of the premises in there is if you have a possible solution that takes 10 minutes to install and has a 5% probability of success, or one that takes an hour and a half and has a 60% probability, which one do you do? Well, you do the simple things first. Do the 10-minute one. If it works, then you've saved an hour and a half. If it doesn't work, you really haven't lost that much with it. But try the simple things first. Sometimes they will fix the problem. Be prepared to change your approach. If you get into the middle of it and something's not working, you may have to change how you're doing these things. Try the easy solutions. How should it work? And that's all part of baselining. What's it like normally, and what changed? Is it really functioning normally? We just don't know it. But what's normal? And you need to know that, particularly on network activity and network traffic, because you may get bogged down on occasions, because at 8 o'clock or whatever time work starts, the system's going to be pretty busy with everybody logging on and getting going on the first things, getting documents from the servers, those sorts of things. You need to know what normal is different times of the day. The functional approach, the top to bottom or bottom to top of the OSI layer in the divide and conquer, but what's not working, and that's what the modular OSI model really should help you with. What really isn't happening, and the tools Wireshark can help you find a lot of things in these approaches. The end user, operating system, and application software. Remember, it's not part of the OSI model, and in the networking world, we're not troubleshooting the computers or the Microsoft Office or those things. What we're doing is looking at network connectivity. Now, they're going to wind up being involved, but what's going on with this thing? Because our applications up here are not Office or not Excel or Access or those things. Our applications are the web servers, the email servers, the FTP servers, communication servers, those sorts of things. And what's going on here says stateful application layer security appliance, this is a firewall, would operate up here. As that causes the issue, and then multi-layer switches would be here. When they're talking about multi-layer here, we're talking about application, things that can actually filter, look into the traffic at the application layer that's going back and forth so that you can see what people are doing in there. And then the network, the IP address, and Antrell and I were working on a thing here, and I sent you a note. I think I know the answer, Antrell. We had the wrong network address.
Yeah, I saw that you sent me.
Yeah, and same thing happened to me, and I didn't have enough of it. When you look at, you can look at the. By the way, this is in, what was that, Lab 8 on the IP where you put the EUI, to make the EUI 64 address. Once you do the MAC part, you need to look on the server on its IPv6 address to find the actual network address, or you can look at the instruction. It actually will give it to you. You can pick it out of it too if you count backwards for the 64 bits for the address itself. But anyhow, the IP addressing goes here, and that was one of the things that happened to us. It wouldn't put it on the network because it had the wrong network address. One of the things that happened to me years ago with DHCP, I was going to be really clever and set a class up and not give the DHCP addresses on the network that it was on, but a DHCP server won't give an address out unless it has an IP address on that network, unless it's configured as a forwarder. Basic firewalls are here and routers are here. Are the packets getting somewhere? And we looked at some of the tools for routers. Ping and traceroute are the two of your most useful tools. There are some visual trace routes that can help you out. There are a number of them. Some of them are free, some of them are pay. Some of them give you a little bit, some of them don't. At the data link layer, the MAC address, we had, and this was in a virtual environment years ago, so I've done a lot of dumb stuff, but I set up a network for a class, and it said that I could either copy the machines or move the machines. I decided I'd copy them. And when we started them up, sometimes they would work and sometimes they wouldn't work. And then finally did an ARP-A and found out that we had a whole bunch of IP addresses with the same MAC address. Well, that doesn't work very well. Does that happen very often? No, but I was at a meeting one time and somebody said, hey, we got a whole bunch of MAC address, or a whole bunch of NICs that had the same MAC address on them. And you put them in, and it's going to be, sometimes they'll get there and sometimes it won't. That the things that you can't make work consistently. Bridges and switches, obviously at this layer. And when we get into the switches, in the bridge you're probably never going to see, quite honestly. Get into the switches. Does it affect a single machine? Does it affect the whole machine? If it affects a single one, then that becomes a much easier situation. Layer 1 and Layer 2 are the network addresses and access points. The physical layer is the transceiver. The transceiver goes with the NIC. A transceiver is a transmitter and receiver. It transmits and receives the signals for these things. You may have media converters when we go from one type of media to other. Hubs are there, but you're probably not going to see them. Hubs, if you get a lot of traffic on them, are going to cause you some issues because they just can't handle the kind of traffic that we do today because of all of the connectivity and all the really cool looking stuff. We don't use text pages anymore. We use all sorts of pretty pictures, and that drives them, and that would drive a hub crazy with that amount of traffic. Test the theory, isolate the problem to a single component or a system. And that's all part of how all this stuff works together. Run tests to prove the theory, and this escalate if necessary if you can't do it. And when you get into troubleshooting, you're typically going to have, I won't say problem too difficult, because the problem not too difficult for you is just beyond where you're allowed to go. Because different levels of troubleshooting are allowed to go so far to resolving a problem, and then the next level has to pick it up. Warranty or supplier issue, you don't want to void the warranties. We got some servers one time that had I think the wrong type of hard drives in them or something, and these were Dells, and we had to run their software to tell them that it wouldn't work, even though we knew it wouldn't work. So it's a warranty issue. You got to do what those guys tell you want to do. Scope's too large, too many, too whatever, but it's just too big of a problem. And then customer issues. And I think one of the things you don't want to do here in the test of theory, you don't want to insult the customer. You don't want to insult the user. So we do the next step of theory. If the theory is confirmed, we'll do the next step. If it's not confirmed, then we go back and start over. We'll go back up to the previous slide and start working on those things. Establish a plan of action. So plan changes carefully. You need to do that. One of the things in plan changes correctly is try it on one machine and see if it works. Particularly if you're installing software or updates on servers, if you can put a virtual machine in that's set up, and you can transfer one from a physical to a virtual. And if it is a virtual, all you can just copy the hard drives. But try it on a machine not on the network, not in the production network, so that you can see what happens, to see if it causes a real problem with you. The other thing when you start making changes, one of the things that you're going to have to be able to do is to undo the changes if they don't work. One of my students worked for Advance Auto, and when they started to make changes on the network and they scripted everything, they had to come with a script that would undo the changes if it didn't work. So you have to be able, you really need to be able to go back if something doesn't work. And in virtualization, you can make copies of it, and everybody's got their own word for it, but you can make a status of what's going on right now, a snapshot, and then if it doesn't work, you can go back to the snapshot time. Try to anticipate the effects. If I do this, what do I think is going to happen to the system? Typical options, we can repair, replace, or ignore. Not all problems need to be fixed. Not all problems are worth being fixed. I mean, it's just like when we go back to security, we're not probably going to spend $10,000 to support to protect a $100 piece of equipment. So you've got to make those decisions. Sometimes it is quicker to, cheaper to, particularly today, to replace rather than to repair, because repair is going to, you got to figure out how much time it's going to take the tech to do that, and it's going to be their hours that are going to factor into the cost of the repair. So replace could be an issue. Ignore, if it's not a big deal, it's not really affecting anything, to ignore as long as it doesn't cause problems, doesn't cost you anything in the troubleshooting process. Implement the solution. Authorization, is escalation required for this, notification and scheduling, and change control. Change control, document what you've done so that if it doesn't work, it gives you a way back. Although in the larger organizations, you're going to have a script that will undo what you have done. Verify system functionality. Consider the impact of the overall system functionality. What has happened here? Test that the problem is fixed. And that may not become, and the system functions normally. This may not happen that the problem is fixed. It may, and we hope it is fixed, but it appears just fine, and then 3 days later it reappears. Then we may have made some progress in it, but it may not be completely completed at the time. Identify preventive measures that will prevent the problem from reoccurring. That means that we have to know what caused it in the first place, and if we know that, if we can determine that, and that's part of what goes on with logs, then we can prevent those. And sometimes that may be making a change to Active Directory so that users can't do something, that you find out that they could do something that you didn't think they would. One of the odd things early on that Active Directory allowed users to do was join the domain 10 times with 10 computers, and that really wasn't a very good thing because somebody could bring their own personal computer in, connect it to the network if we didn't have proper layer 2 configurations, and join their machine to Active Directory, and that may or may not have been of any value to them or any value to anybody. Ticket system. Do you use a ticket system? Tamika?
Yes, sir, I do. I'm sorry, I do.
Yeah. Because
ServiceNow is what we use right now.
I'm sorry?
We were using Remedy. We're now using ServiceNow.
Yeah. So they have to report the problem in writing, right?
Correct.
And
Yes,
you know when it occurred, what time you got the ticket, and then you can document what you've done on the ticket. Who did it, who it's assigned to, when the due date is, what you're going to do with it to due time, all these sorts of things. So the ticket system is one of the things that really is helpful in troubleshooting. And there are a number of softwares available, and
yes, it is.
and some of them are easier to use than others.
Yeah, it's more of CYA though.
Exactly. Yeah. So that you say, oh yeah, we did this, right? But why isn't it still not working? But you can document these things, and if you use these things, you can categorize them, record them, and then that's going to help in the categorization and identify trends. Is something going on? Or hard drive starting to fail at an unusually high rate? If that's the case, we need to go back and see, is it a particular manufacturer? If it's a particular manufacturer, how many of those do we have? Has the manufacturer made any changes? Have there been any upgrades? Have there been any BIOS changes? Those sorts of things. So what's going on? And what do we have? Where are the failures? Are there upgrades that we don't have? Add known issues to the knowledge base, and those things can come and go. Complete the notes fields professionally, so that you want these documents to be useful and usable when you do these things. So it does need to be done professionally. End-to-end connectivity, and these are some of the things that may happen to you. What tool are you going to use for end-to-end connectivity?
What tool?
What's going to tell you that you can actually get there?
Point to point.
Point to point. How about ping? Ping and traceroute.
Oh, okay. What? Somebody help me out. Okay.
But those are kind of these are, you're just going to look at if one system's affected the star wire topologies. The star topologies, we're really talking switches here. If one computer is affected, one station's affected, you need to check the link between the switch and the host. And the things that it could be, I would start at the bottom. Could be the wire. Does it work? And you're probably, you may have a couple of wires involved, or you may not. But if it's one system, is the wire good? Are the link lights on both the NIC and the switch port? If that's the case, or is the port good on the switch? And the easiest way to do that is to change the NIC, change the connection, pull the wire out of one and put it in the other one. You're probably not going to create a loop there because you're not going from switch to switch. You're going from a computer to a switch. The one thing that may happen if you've configured the switch that will only accept certain MAC addresses on certain ports, it may not work then. But typically, one computer doesn't work, one machine doesn't work, it's going to be between that machine and the switch because everything else is working. It's like, and I'm sure that she gets this in troubleshooting. Something's working for 150 people and it's not working for me, then there must be something wrong with the system. I get that all the time on this organization that I try to help out, that I can't get on this area because it's broke. Of course, we had 400 people get on it in the previous part of the day, but not them. So those really are the kind of things that are going to happen to you, or the server forgot my password. That's unlikely. Or tell me what my password is. You can't do that. You can reset it for them, but you can't tell them what it is. If more than one system is affected, check the backbone wiring between switches or the switch itself. I would start with the switch itself. We would work our way up. If it's a single system, probably going to be on that machine, or it could be on that particular port. And one of the particular port things that could be an issue is that port's on the wrong VLAN. We talked about VLANs and switches, and we do those things. So when you start doing this, there are a number of things to check, and then the VLANs, did something change when we do this thing? So more than one system's affected, check the backbone wiring, what does work and what doesn't work, and that's going to be one of the big deals. Part of the network works, part of the network doesn't work. The half over here, and it's on a same set of wiring, and we haven't done any kind of redundancy, then could be an issue with the connectivity there. Backbones, question determining which host can see which other host, how much of the network is actually working. And when you start talking about those things, a network topology drawing can become very handy. How does the network wire up? Things that we hate to do, documentation, but what's connected to where? And you're going to find out, I think, later on that you really need to know, even down to the port, what's connected to what port, because things are going to happen someplace, and it may or it may not be the issue, but a wiring diagram is really handy to have. And when you start troubleshooting, it becomes handier to have which one goes to which switch. Did we plug the IP phone into a non-power over Ethernet? Did somebody plug it into a non-power over Ethernet switch port? So wiring diagrams can be important too. Mesh topologies, they're difficult because if a mesh is working right, you may not know that something broke, because the mesh has everything connected to everything else, so that we can have the system stay up consistently over time. So they may or may not help out or be easy. They're not easy. They're difficult to troubleshoot because the hosts have connections to everything else. If host A and B could communicate using 3 routes and they used to have 4 routes, then troubleshoot the 4th route. There may be a wiring problem there. I think one of the issues here would be determining that there was a 4th route, unless you get into that one of the routes is down, unless you get into we're really having some connectivity problems, slowing down or whatever else, or unless you are testing the paths with something like traceroute to see where your information is actually going. Power anomalies, surge spikes, and brownouts. Surges and spikes are the things that we always worry about, but the way power works, brownouts are probably the most hazardous to the electronic components. Surge, we have things to protect with surge protectors. Spikes, surge protectors, although they may or may not actually do you any good, and many of them are one use. If the little light's flashing and the on-off switch, it's probably not good anymore. But the brownout can be an issue. Blackouts obviously are an issue because you don't have anything in a power failure. Not a whole lot of troubleshooting there. There's a lot of planning there that goes into that, the UPS, the uninterruptible power supply, and how long is it going to last. You'll see places like hospitals the big companies are going to have diesel generators as their UPSs. You may have something that goes on battery power immediately, and then the diesel starts up, and that standby power would be an issue there. UPSs, you may or may not have a UPS at home. Power monitoring, what's going on with the power. We can also have power conditioners, which are going to level it out. A number of places have some dirty power. They tell me that it is here. I haven't really had any issues yet, but a guy next door said he really wants to put a power conditioner on his system so that it will filter out a lot of the little spikes on the in the power itself. Many UPSs work that way. A lot of the UPSs work with the alternating current, charges the battery, and then whatever you're running runs off the battery. Some do and some don't. It depends on how sophisticated and usually how expensive it is. Cable placement, bad wiring or cable length. The first step is to isolate the issue. Ping, connectivity. Ping is one of the tools that is going to be your best friend here. You ping from you to somebody else, how far will the ping go? And this is going to tell you a lot of things. Can you ping yourself? Can you ping the gateway? Can you ping across the gateway? And if each of these things are going to give you an indication of not only configuration, but what's going on with the physical area as far as the cable itself. So to verify the patch cords, typically you're going to have from a switch, you're going to have a cable that goes from the switch to the computer. But you need to check those to be sure they're good. If they're commercial, patch cords are probably going to be good. If you made them, they kind of wear over time. Things happen to these things like the little tabs break off and you can't lock them into the NIC or into the switch and they back out. If you're in a relatively humid environment, which the Dallas people are and the Colorado people aren't necessarily, but you can get little bits of corrosion on these things. Sometimes, and remember, these are really, really small voltages that we're talking about. Sometimes if you unplug it and plug it back in, it'll break that, and then it goes back to, oh yeah, golly, what happened? Why didn't this work before? Somebody trips over the cable, breaks the cable, kind of breaks the cable. And I told you back when we were actually using the bus with the coax, they would undo the connectors and make it look like they were connected, but there was no, it looked like a physical connection, but there was no electrical connection, and the whole network would go down. Loop back on the host, the cable placement, loop back on the host and on the switch port. Is it working? And there are lights that will give you a lot of information. I'll go back to ping, and I guess the question there, can you ping anything? And that was always the first thing we started with, was ping. What can I ping and what can't I ping? Well, I can ping myself and that's it. Could be my cable. Test permanent links and interference sources. Interference sources are probably mostly going to be in the wireless world, and there are a number of interference sources. People talk about, they have the break room and they got a wireless network in there, and at lunch you can't really get out because people are using the microwave, and microwave ovens interfere with wireless. You have two access points and they're on the same channel and they're really close together. They're going to interfere with each other. So do you have interference sources? Somebody just put in a big power line across the network. That could cause interference. That could cause lots of interference. What are the sources? What can cause these things? If you put cable close to fluorescent lights, can cause you some issues, because the fluorescent lights, remember, not a solid light, they turn on and off, so they actually have a frequency that can affect a bounded cable. Not necessarily wire. It can affect wireless, but it can affect a cable, copper cable. Then we may need to go to something like fiber optic. Network adapters, what's going on with them? Hardware failure or driver problem. honestly, I know Timothy had a hardware failure, but hardware failures are rarer and rarer today. They didn't used to be. Used to be NICs would fail on a semi-regular basis, but they tend to be pretty good now. Most of them are part of the come as part of the motherboard itself, so not a whole lot of NIC changing. But is there something wrong with it? And is its configuration correct? And they say here the speed in the duplex. If we have, I didn't want to do that. There it is. Speed in duplex. If we have a mismatch, it ain't gonna work. If we have a 10 megabit connected to 100 megabit, it's going to be a no megabit. The newer NICs, the new systems do auto configuration, so you can just set the NIC up for auto, and they will negotiate the speed and use whatever the highest, the lowest common speed is. So they can do that. The duplex mismatch, full or half, and again, they'll do auto negotiate, but if you configure them manually, you'll have to know that, and that should be part of your documentation, that this one is configured manually for some sort of a reason. NIC teaming misconfiguration. NIC teaming, remember, is when we put two NICs together and run it as we have a big wire here, as a single connectivity point. Active-active means that they're both working at the same time. Active-passive means that one's carrying the load and the other's waiting for it to fail so it can pick up the load. Incorrect port assignments on these things. Multicast or broadcast heartbeat probes are blocked, and this would be going across some sort of a network, and they do have heartbeats that and that's the name of the protocols, heartbeat protocols that have to be available, or it detects. I mean, that's the way that the system knows that the other half is working. Incompatible switch, a switch that does not support NIC teaming, and some do and some don't. The newer ones should all do that. And over here they talk about port 1, the interface. The interface is 1000 copper. Admin status enabled. This is just some of the properties of this thing: back pressure, flow control, speed. And one of the things, and they may give you on the test some troubleshooting problems that you have to look at a console and see what's going on. I think that they have one on wireless, and what you wind up, we haven't done wireless yet, but I think they wind up with a duplex mismatch, a speed mismatch, and a channels are too close together, and protocol mismatch. One of them's a G and one of them's a B. IP configuration in the default gateway. Check the configuration. This is an area that can be a problem, but the thing that's going to help us not have a lot of those problems is a correctly configured DHCP server. The good thing about DHCP is it works really well. It's a really simple protocol. The bad thing about it is if you get it misconfigured, you get a whole bunch of machines misconfigured. The IP address, subnet mask, default gateway is static or DHCP assigned. If they're DHCP assigned, they're probably either all going to be right or all going to be wrong. Go back to DHCP in a second, the DORA thing, and once you get an address on DHCP, you keep that address until the server says no. The system will try to renew it at 50% of the lease time. If that doesn't work, at 87% of the lease time, it'll request any DHCP server give it an address. At 100% of the lease time, it'll give it up and it won't have an IP address. And the 50% is how we kind of maintain our persistent addresses from the ISPs, from whoever your provider is. Ping. First we want to ping the loopback address, and then ping your own IP address, ping the default gateway, and ping across something across the gateway. If you ping the IP address of a system and it works great, and then you ping the name of the system and it doesn't work great, the fully qualified domain name, then you got a problem with DNS. We used to have a thing in Active Directory that the students could ping the IP address. It works. Ping the name now. Doesn't work. And if you ping the fully qualified domain name, will be different from the host name. So if I ping mycomputer.mydomain.com and it doesn't work, and I ping my computer and it does work, then DNS is still a problem. All of those things are going to be what's going on. Discover neighbors, check the ARP cache. ARP-A will list that, and then the Discover neighbors is the IPv6 replacement for ARP, where the list of NIG has a list of it. We'll find neighbors, and I think it's one of the labs that you look at it doing the neighbor solicitation, where it lists all of the neighbors, the machines that are on the same network. And then we'll ping a remote host to see what's going on here. The default gateway, check the IP of it, check the link to the default gateway. The link is the cabling okay to it. Duplicate IP addresses. What you're going to get on a duplicate IP address is the system will shut down both machines. Before a computer actually goes online, it does an ARP to see if its IP address is already in use, and if it is, it won't use that address. So that helps a little bit, and I've forgotten what the name of it is. You'll see it in Wireshark. It does an ARP to check to see if the IP address is already in use, and if it is, it won't use it. It won't bring it online. So that helps that out sometimes too. Incorrect interface or wired wireless interfaces operating simultaneously. Different things, and these are things that should be like the first time it comes online. It shouldn't happen. Computer's been running for 6 months, and all of a sudden that we have the incorrect interface or some wiring bad. Somebody's been doing something on the internet, on the network, if that's fine, if that's a problem. But here, the ping the loop back, ping the host, ping the gateway, ping a remote host, ping a host name, and then I would ping a fully qualified domain name. A number of places won't answer. If you ping www.microsoft.com, they won't answer. Yahoo.com will answer. So a number of the big places won't answer when you do the ping, and if the first one doesn't work, try another one to see if that works. The wrong DNS or name resolution. Verify the name resolution sequence, and part of this is we're going to use Netstat to do that. Check your own name, search the host file, search host. The host may or may not be significant, quite honestly. There is a server called Wins server that lists the hosts. You can either use the host file, you can use it. Not all that popular anymore. Microsoft's really tried to do away with it, and I think that for the operating system itself, you really don't need NetBIOS, and NetBIOS is where the hosts are going to be. So query DNS, does it work? And we're going to use Netstat to do that. Netstat, we're going to use, what are we going to use to do that? We're not going to use Netstat, are we?
MBT.
MBT stat will give us, that's going to be for the hosts. When we're querying DNS, what were you using? You were just doing the lab.
The IP config.
Huh?
IP config.
IP config will tell you what yours were. Which lab were you doing when you did the set type equal MX? What'd you say?
Netstat, or is it?
Now Netstat's going to tell us what's connected to us. See, there's an awful lot of utilities.
NS lookup.
NS lookup.
Oh.
We can test DNS, and you may not have done that one yet, but you can test DNS with the NS lookup. Is it working? Is it listed? Can we get an IP address for that machine? Test the
Right, right.
services with the hosts, and the hosts, and when we looked at MBT stat, it showed you the host services. Again, that's probably the only time, I think, and the only time we had a couple of applications that ran, a couple of testing applications that needed host files, but not very many, and there are fewer and fewer and fewer of them. So the host's name itself, using it with the Win server or the broadcast or whatever we're doing with those, are becoming less and less of an issue, and DNS is becoming more and more and more of an issue. So we're going to check the client's DNS server address. What server is it going to get the information? When we're talking these things, we're probably really talking Active Directory, because if we're going to the internet, we don't really honestly care a whole lot about what DNS server it's using, as long as we have a caching server or something that'll go out on the internet and get it. But when you're talking Active Directory and you're trying to find individual services, individual computers, and individual servers, you need to know which DNS server it's using. And check server availability. Is it up and running? Those things, and the services kind of quit occasionally. And sometimes they get corrupted files. Any power problems with Windows can cause corruption of the operating system. Internet work was more than one user affected, and this is back to all the things that we were talking about. Verify the logical topology of the network diagram we talked about. Hardware failure, maybe. And the old, what's going to fix a Windows problem about, what, 90% of the time? Reboot it. Do you guys do that a lot, Tamika?
Yep, that's true.
Just first, did you reboot it? You got to be careful about those guys sometimes, because there was somebody on the help desk doing that, told them to reboot the machine, and they said, okay, I did that. And they finally went down to watch what they were actually doing. They would turn the monitor off and turn it back on. And that was their reboot. So you need to be sure that they really know what reboot is. I mean, that's where connecting to them is an issue, because you can go in and do the restart for them. Firmware updates, are they done? And before you do the firmware update, how's it operating? Try it out, because sometimes you do the firmware update and things just don't work so well. Last thing, you may have to swap out. You may have to swap out components. You may have to swap out a whole system. We'll pick on Timothy for that. He had to swap out a whole system. VLAN assignments, we kind of talked about that, but check the configuration. Are the users on the switch, are the users assigned to, are the ports assigned to the correct VLAN? Check VLAN membership, which ports are assigned to that VLAN. First, services available, because if you're on a VLAN, you have to have routing. DHCP relay agents. IP helper is the relay agent that runs on the Cisco router. Is DNS available? Authentication and network applications. Can they authenticate from that network? And that kind of going to be related to DNS when you get an Active Directory, because a DNS server has to be available to find all of these resources. Loops and black holes. Switching loops. I did the little demo, and hopefully that made some sense on the switching loops. If we get switching loops and broadcast storms, it's going to shut things down. The thing that stops switching loops is the protocol that we use there, spanning tree. Because if we have a routing loop, it'll eventually run out of time to live and just get quit, and it will quit. A switching loop has nothing like that to stop it, so it'll go on forever. That's why it really does become important that if you have a big network and you have redundancy and you have physical loops, that you have spanning tree running so that it breaks those loops. Route problem, missing routes, just can't go anywhere, and you'll get an ICMP message to tell you about those things. Routing loops are you can actually kind of see them. I want to show you that one again, maybe, if I can get the command prompt up. So on this one, and this is a pin. I immediately get TTL expired in transit. The next thing that and this is from the 15.2, and this is going to be a router. If I do a trace route, and I'm going to dash details it not to do DNS lookups, because the DNS lookups are the things that really take a lot of time. We'll go through this, and it's going to do fine until it gets near the destination. One of the switches, or here this router 10 operates pretty slowly, and this is how many hops do you get there. These things go long distances. So this is going 15.2, goes to 15.1 to 15.2 to 15.1 to 15.2. So we have a routing loop going here. It's just going back and forth from one to the other. I guess then we can let it go and see how far it goes, because it will eventually time out. 30 hops, trace complete. But we really didn't get there because we got into that loop, and you can see the loop going back and forth in that. That would not happen at a layer 2 loop. It just would shut down your network due to overloading of the switches. MTU and MTU, maximum transmission unit, black hole here. What's going on with the MTU? Do we have an MTU problem? IPv6 is going to be a lot more efficient in that IPv6 checks the whole path before it actually starts sending anything, so it knows how big of a packet can be sent. IPv4, we leave it up to the router to determine whether it can go across it or not. Typically, it's going to be okay today. The new routers can handle much larger packets than the old routers could. If you're using something on a local network, you may want to, and this would be layer 2, you may want to go to what's called jumbo frames, which will carry more traffic on them if both ends and the switch supports that. DHCP is a pretty simple protocol. Not a whole lot happens, and here server offline is the big thing. Address pool exhausted, that could be, I used to work at a place where that would happen to us because the servers were set up to automatically reboot on Saturday night, and for whatever reason there was some really weird DHCP getting everything. We would have one of our networks would have, when we came in Monday morning, would have no addresses available, so I go back in and delete all the really weird addresses. But you can exhaust that pool when it happens. You just don't give any more addresses out. No DHCP relay if we're not on the system that the DHCP server can see the broadcasts. The DHCP relay is going to be necessary to intercept the broadcast and forward it via unicast to the DHCP server. This can be done by the router in most cases. IP helper is the Cisco one. Scope's misconfigured. If you have a scope and you're trying to give out IP addresses, you need to have an address on that network for it to send them out on. Duplicate services, and I think somebody asked about that. Duplicate DHCP, you can have that, but be sure that your scopes don't overlap, or you'll wind up giving the same IP address to multiple systems. DNS, client server, the client DNS suffix, the server's offline in NSLookup, and we want to use NSLookup to verify what's going on with DNS. These two things generally are going to work as long as they're connected to the network and we don't turn them off. Occasionally I've had when a server starts up that this service didn't start, but that's a matter of going back into the services executable and checking that. DHCP is really simple protocol. It either works or it doesn't work. There's not a whole lot of configuration that you can do with it just to be sure that it's running and that you have an address pool. If you go in and look at it and the address pool's exhausted, it'll tell you, it'll have all sorts of exclamation points around it. It'll be obvious that something's going on with your pool. So with that, I guess we could look at these questions. You ready? See, we're getting closer to the end of the day. I know that breaks your heart. What are the two basic principles of identifying the cause of a problem? I know somebody's there. What's one of the first things that you want to find out?
I guess what's going on.
What's going on? Yeah, that's true, but what?
What, can you duplicate it or?
What changed? Because it worked yesterday, right? What changed? And then test one thing at a time. Just do one at a time when you do them. This is one that, and probably reading the book will help on it, and doing test bank questions will help on it, because this is CompTIA's concept of how troubleshooting works, and that's the way you got to answer the questions. Because we used to say in the Navy there's a right way, a wrong way, and a Navy way. Well, here there's a right way, a wrong way, and CompTIA's way. Now, CompTIA's way may be right, not always, it's not wrong, but it may not be the way you would do things. But you got, for certification tests, you got to answer it the way they want it. After asking 3 basic questions of anyone reporting a problem, what should you have determined? Hmm?
Oh, wait a minute.
What should you have determined? Antrell's talking to us and he doesn't know it.
I know, I'm thinking out loud.
Okay. So what, after you ask the questions, what do you want? What do you think you should know? Because the first thing we were supposed to find out was, in question 1 was what?
What changed?
What changed? So what would be the first thing you would know?
Look for recent change or oversight.
Yeah, there are recent changes, yeah. I guess these are true falses. These are, yeah. What about where to look for the problem? Because these are listed in the book. These are true false.
Yeah.
Yeah. The severity of the problem?
Yeah.
If the problem should be escalated, would you know that in the initial questioning?
No.
No. You're gonna have to. You need to go a little bit farther before you know before you can determine whether to escalate it or not. In what sort of circumstances should you escalate a problem?
You can't figure it out.
Can't figure it out.
Yeah.
Yep.
Beyond your skill level.
Beyond your skill level.
Warranty.
Warranty. All of those.
There was a third one, wasn't there?
Yeah, probably. But let's see. Cannot solve it yourself. You don't want to escalate it. You don't have authorization to perform the necessary tasks.
That's what I was about to say.
Yeah. If you detect a significant increase in noise affecting a cable link, how would you go about determining the cause?
Try another cable first.
How about what changed?
Yeah.
So it is likely that some equipment or power cabling has been installed near the data link cable, and that those things do happen occasionally, particularly in large organizations. Small organization, you're going to know what's going on. When troubleshooting a cable link, which should you investigate first? The patch cord, permanent cord, or network adapter?
Network adapter.
You know, they say patch cord, and I would always check the cable first, because they're out there. People unplug them, people play with them, people trip over them, depending on how well you've got it set up. Tabs break, they become corroded. I'm sorry, I keep interrupting.
No, when you think patch cord, you're thinking of a switch, but they're talking about patch cord at the computer. Make sure it's plugged in. That's the first thing
Yeah.
you do actually. Is it plugged in?
Yeah, is it plugged in and is the link,
And you look
and
back at the-
is it plugged in or are the leak lights on?
yeah, well, if you go look at the link lights, you see the plug's missing. So
Yeah.
if that makes sense.
I used to have a class
That's-
and to
that's
try
a
to
part.
try to teach them, and we use physical machines obviously, to try to teach them about getting the physical connectivity, I would disconnect all the cables. And they say, I can't get on the internet. Now to look at their NIC and say, I agree. All you had to do is look and see there was no cable plugged in. You don't know how many times that's going to happen to you either.
It's not like a
Huh?
I'm kidding.
You've never experienced anything like that, have you?
Oh, yes, I have.
I'll bet you have. You've connected a new computer to a network port and cannot get a link. You have tested the adapter and cable and can confirm that there are no problems. No other users are experiencing problems. The old computer also experienced no problem. What cause would you suspect?
Your Nick.
That's what I would say, the NIC, but since it's a new computer, of course, since it's a new computer, there's no guarantee that the NIC's good, but if we assume that the NIC is good, configuration problem, they say a speed mismatch, which means that it's set up for a manual speed instead of automatic, and I expect that most of them are going to come with automatic unless somebody's been fooling around with it. So you want to be sure that auto negotiates on those things.
You're talking about the NIC config for the FPGA.
The NIC setting for auto negotiate. Actually, yeah, the switch is unlikely to have been changed. What I would do, honestly, is go to another switch port also, because I would suspect that they don't fail very often, but switch ports do occasionally fail.
Yeah, but in that question, they said the adapter and the cable, and the old computer worked. You're assuming it's on the same port, so it
Yep.
would be the NIC.
Could be the NIC. I mean, there are a number of things there, but they want speed mismatch. Could be duplex mismatch too. I mean, that's as good. That's good as an option as anything else.
Of course, the NIC config, that is the two main things: the speed.
Yep. Yep. The duplex and the speed. And I'm with Tamiko. My first reaction would always be NIC. Users on a floor served by a single switch cannot get a network connection. What is the first step?
Which
I
powered
would
on.
take the back of the courtroom.
I would look see if the power's on. Reset the switch. Yeah. Turned off. Reset. Turned off.
The answer is look at the switch.
Yeah. The reason I say the power's on, I have seen that happen in a room. An instructor was in a room and went the whole night, and the next day said, nothing worked in that room last night. Nobody could talk to anything or anybody. You go and look and it's unplugged. It's unplugged.
Well, I had that where they turned the light on, they worked on it, they said it was working, then you turn the light off, leave the room, and it stopped working.
Yeah, because you had, and that happens. You have some places you have the
wall switch.
yeah, turned it plugged in. You be careful about things like that. That does happen. Or the server went down at the end of business every day when they left the NOC and turned the lights out.
That happened in a house. The house was converted to an office.
Yeah. Yeah, those kinds of things. It can happen in other It can happen in other places too. Well, like he said, look at it to be sure that the lights are on. Is it actually on? Let's see. Reset the switch. You have pinged the router for the local subnet and confirmed there is a valid link. The local host cannot access remote hosts, however. No other users are experiencing that problem. What's the cause? What are 3 things that you really need to put on a machine? Actually, there are 4 things that you really need on a machine for it to communicate.
IP address.
IP address. About gateway, so that it knows how much is network. How's it going to know how to get somewhere? Default gateway. And the other one that it needs is DNS server unless you're just going to use IP addresses. So this one probably is that the router's not configured as the default gateway. Following the maintenance on network switches, users in one department cannot access the company's internal web and email servers. You can demonstrate basic connectivity between the hosts and the servers by IP address. What might the problem be? We can get there by IP address, but we can't by name. What's the issue?
DNS.
DNS. Says it's likely the name server. Network monitoring software can detect broadcast storms. What is often the cause of broadcast storms? And we didn't say this, but let's see what you come up with.
Switching loops.
Switching loops, misconfiguration of spanning tree.
That's right here.
An unauthorized or unplanned attachment to the bridge or noisy NICs can also cause it. These things happen. I told you about the guy that used to teach with us who put in a network and it went down. It was a brokerage firm or something in Chicago, and he went up, flew him up to Chicago, and he moved one wire, collected his consulting fee, and came back home because somebody had moved. They didn't use spanning tree. Somebody moved a wire and created a loop, brought the whole network down, all 10 floors.
And he probably got paid a few grand for that.
He did for move one wire. It's not what you do, it's what you know. Not what you do, it's what you know.
He was in cahoots with somebody.
That could be. They ever find out who that is, oh, he's going to be in trouble, he or she. What is an MTU black hole? And I didn't go into that. I didn't tell you this. A router drops packets. Huh?
That's the routing loop?
Yeah, now if it drops packets with the MTU exceeded, it doesn't fragment them, it just throws them away. When a router drops a packet, you should get an ICMP message back. Now, to get that ICMP message back, you've got to be sure that you're in one outside your network. You got to be sure that your firewall is configured to let those messages through. And that sometimes you don't get them because they are blocked. You're planning to, I'm sorry?
That's misconfiguration of the router.
Yep, configuration.
So it's not passing the packet.
It's configured to drop them, yep.
Yeah, okay. So the answer would be misconfigured router.
Well, it's a router that drops packets, it may or may not be as configured, that drops packets that exceed a permitted size without notifying the sender host of dropping the packets. That's why it's called a black hole. There's probably something wrong with it, or misconfigured, as you said.
It drops a packet when it doesn't route the packet, right?
Correct.
And then if it doesn't know where to route the packet,
it drops the packet. If it doesn't know where to route it, it'll send it back to you and say something like host unreachable or network unreachable. Network unreachable typically means that it doesn't have a route there. Host unreachable typically means that the host isn't online. If you're planning to reconfigure static and DHCP assigned IP addresses across the network during scheduled downtime, what preliminary steps should you take to minimize connectivity issues when the network is reopened? This is one that I've done. So we have the DHCP server, and what we're going to do is, let's say we're going to go to a new network. How long does a DHCP server give you the lease for?
48 hours.
Depends on that's the default, but it depends on what you configure it for. You can configure the lease time. So what we did was configure the lease time for a very short period of time when we're getting ready to change the addresses, you know, like maybe 2 hours. And then when they went down, they got those addresses. When you bring the network down, change it, when they come up, they're not able to renew that one because the lease has expired on them. So they say ensure that clients obtain a new DHCP lease either by shortening the lease period in advance or by using a script to force clients to renew the lease at startup. What systems will tend to do, and if you're in a in an environment where you go in every day and do that, look at your IP address and look at it the next day and see if it's the same. If the lease doesn't expire, it's probably going to get the same IP address again. Okay.
So the answer is shorten the lease time.
Yeah.
So
When you shorten the lease time, and then they'll have to get a new lease, a new IP address when they start up, if you can get it to where they're off. That it expires while the machines are off.
Right.
Because generally they're just going to renew the same IP address if the lease time goes over the amount of time that they're off. I think we used to do ours for, I don't know, 14 hours, 18 hours, something like that, so that they would actually last overnight, but they wouldn't last over the weekend. With that, let's take a break. I had you go too long. Let's start back at maybe how about 5 minutes past the hour. Will that work?
Enough.
Okay.
Enough.
So what we want to do in this one is look at applications and services. Applications are the layer 7 of the OSI model. And when we look at these things, the objectives here describe the functions of web and file transfer protocols, describe the functions of communications protocols such as email and unified communications. The basic elements of QoS, quality of service, and quality of service allows us to give certain types of network traffic more priority than others. The functions of applications and packet shapers, load balancers, and multi-layer switches. That one's a mouthful, but it's pretty straightforward. The web services, HTTP is the unsecure web server, uses TCP port 80, URL, the Uniform Resources Locator, to get there, and HTML, hypertext markup language, is the language that it uses. And we all use the web services every day. The web services are provided, served up by a web server at some place, and we need DNS, unless we know the IP address for every place that we go. We need the DNS server, and that doesn't always work because sometimes you have multiple websites running on a single server, and when you get there, the IP address gets you to the server, and then the server directs you to the correct website, the correct URL. SSL, Secure Socket Layer, and TLS, Transport Layer security are the ones that make us secure. That's when we get the little lock. And it's kind of interesting. I kind of like to go through what makes this secure. How do we know this is secure? Because we have the little lock, right? Anybody any idea why this becomes secure? Encryption? But what if the bad guys encrypted it for us? I can do some bad drawings again.
We'll find out later.
Yeah, that's right. We have this thing called certificates, right? And certificates actually are the things that we use to do the encryption. So encryption is actually the reason that it becomes secure. But what makes it secure are certificates, and we have public certificates which anybody can have, and we have private certificates which only, if it's our certificate, which only we should have, and if it's a website, a private certificate which only the website should have. So when I will be the client here, we'll do a client and we'll do a server. Client, I go to the server and say, hey, I want to have a secure conversation. It sends me its public certificate. And then I create a key, an encryption key, and encrypt it with its public certificate. And something encrypted with a public certificate can only be decrypted with the private certificate. So I send this encrypted key back, and it decrypts it with its private certificate, or its private key, or private certificate. So now we each have the same key, and we can have our encrypted conversation. And we never revealed any of this stuff during all of these transfers. So the keys, the HTTPS and transport layer, that's how we make these things secure, and we always look for the little key. And if you do a Wireshark capture of these things, you'll probably find that the key shifts. And when the session ends, when we close the browser and you go some places, it'll tell you to ensure that this has gone away, close your browser. That actually kills the key. And the next time we start up, we have to go through this process again to get a new key. Protocols to secure, protocols used to secure TCP protocols, HTTPS, SMTP, IMAP, POP. These, I don't know why it says these, HTTPS, okay, SSL, I got it, SSL secure these. These are HTTPS got me going here because it's the secure HTTP. SMTP, all these email protocols are by default not secure. They're just text files. Unless you secure them with something, anybody that can intercept the conversation can read the conversation. Not only that, in POP, if you're out monitoring a network, then you can read the passwords. I had some students one time that we were in a security class and we were doing man-in-the-middle attacks. And I always tell them that when we do this stuff, when you get these softwares, it stays in this room, and you can't use it on anybody else, particularly in this building. If you use it on anybody else outside the building, you get arrested. You're on your own. But they went to another classroom and decided that they were going to run it. So they got the instructors in that room's email password. And not only were they disobedient, they were stupid. They went up and said, "Look what we got." So they were not real popular for a while. But these non-secure protocols with tools, simple tools, and if you want to do a man-in-the-middle attack and try it out in your own network and not somebody else's network, in your own network, Cain and Abel on the internet works pretty well for that. Digital certificates come from a certificate authority. And the certificate authorities, trusted certificate authorities, are the ones that we get these things from, that we automatically, they automatically work for us. What I think I would like to do here maybe is show you where you would find them. I'm going to start Internet Explorer here because it's the easiest one for me to find them in. Maybe start Internet Explorer here. Well, I got it started now. It's got to do is move over here. But you can see where your certificates are. I'll probably mess this up. Internet options. I think it's in content. No, it's not content. Yeah, it is. Content, certificates. We have a bunch of these things. We have other people here. These are other people that I have certificates for. My personal certificates, intermediate certification authorities, trusted root. These are all the ones that you get certificates from, and what happens is that the people that want a certificate send in their public certificate and they get signed at the certificate authority. But these guys, when you go to some place and they have a certificate signed by them, you don't get to pop up and say you're about to go to a non-secure site. Untrusted publishers, there aren't any trusted publishers. Microsoft used to have some in here that were revoked, but I guess that they've expired, so they're no longer there. But that's where you can see where the certificates are. What certificates do you trust? And those things need to be updated on occasion. And they come with the Microsoft updates. But the certificate authorities are the ones that are authorized to publish these things. About a year and a half ago, I think somebody compromised a certificate server and got some of these things, which causes some real problems. That means that nothing winds up being secure. FTP, file transfer protocol, another one of those insecure protocols. We also have an FTPS, which is a secure file transfer protocol. FTP is a kind of a strange little thing. It makes it really difficult at times. It uses 2 ports. We connect to it on port 21, and then the data transfer takes place on port 20. One of the problems with this is that we connect to it, and then it connects to us. Well, generally, you use the next available port for this, but since the server doesn't really know which port you're waiting for it to connect on, can cause a real issue. Passive mode down here, we connect to it on 1030, and then we tell it which port we're going to use for our data connection, and then it allows us to connect. So passive, sometimes you're going to have to go in passive mode in order to actually make these things work. 2021, 21, an ephemeral port, again, is one that's a variable port. It's a random port that we usually call. TFTP port 69 is UDP. TCP FTP runs on TCP. So it is a connection-oriented, or what some people call reliable protocol. TFTP runs on UDP, so it's a connectionless. You use it when you get into the Cisco world. You use it to download the configuration files from the routers onto your desktop, so that if the router goes down and you get a new one, all you got to do is upload the configuration file and everything's going to work again. But we talk about unreliable or connectionless. The TFTP server softwares that I've seen running on UDP, if something happens, the server software is the one that tells you that you have a problem. It's not something that's going to pop up with TCP and it asks for a resend. But you will know, at least on the TFTP servers, that you do have a problem. SMB, server messaging block, is the thing that's available from Windows that allows file and print sharing. The software that you can install or runs on Linux that makes this compatible is called Samba Server. So Samba Server on Linux works with SMB, server message block, in Windows, and that allows file and print sharing on a Windows machine. SMTP, Simple Mail Transfer Protocol, and I always get this messed up when I'm doing these things. I have to say the words because there's another one called SNMP, Simple Network Management Protocol. They do radically different things, but they sound an awful lot alike. SMTP, it says server to server, but if you have an email client and you're sending emails from your workstation, you will have to configure an SMTP server in order to send your mail. You also have to configure either a POP or an IMAP server to get your mail. So SMTP sends it and POP and IMAP get it. Used for mail delivery, these are where the MX records come in. They talk about non-delivery. If it can't be delivered, the email can't be delivered directly, the servers will attempt it, and you'll get usually get an attempted delivery message that says, don't panic, but we can't deliver it yet, and if it's undeliverable, we'll notify you later. And they usually try to, I think, deliver for like 48 hours. SMTP, the sender uses port 25, and these are TCP port. Anytime we're going to get these things, well, that's not true. It is an SMTP is a TCP, and these are all TCP. POP, Post Office Protocol, POP3 generally is going to be client to server. It actually, the mailbox access, POP uses port 110, Secure uses 995, IMAP uses 143, Secure uses 993, and if you use something like Outlook and you try to configure your Gmail account, you're going to have to go get see what they do, and they'll give you step-by-step on which ports to configure for either POP or IMAP. POP is an old protocol. It was designed for dial-up systems to where you would dial up the email server and download the emails. IMAP maintains a connection to the server, and as you get new emails, you know about them immediately. But typically what you do with POP, though, is you configure Outlook, and with POP tell it to go get the email every 3 minutes or 5 minutes or whatever else. So you get them almost in real time. But IMAP, you actually connect to the server. The advantage to IMAP is that as a networker, that the messages stay on the server. On a business, in a business, you really don't want to use POP3 because you can configure the client to download the email and delete it. And you may be legally required to keep them, and IMAP was going to allow you to do that because all the transactions take place on the server. If you delete an email, as you know, it still stays there for a while. And Outlook, web-based Outlook, you can either go into the deleted and look at them for a while. That if you delete it, it goes into the deleted, and then you go into deleted. So it has some capabilities there. The real-time services, the things like we're using now, are available, and obviously available. We can use those as we go through here. And different protocols are going to be used. Voice over IP is becoming more and more popular, and it's taken up some great degree, I guess, of many of the local networks. But VoIP, video teleconferencing, we're using a form of video teleconferencing here. And more popular in meetings. I was in one time. This is one of the big ones that make it look like you're really there. I was in one of those one time, and they're kind of neat. They have huge screens, big wall-based screens, multiples of them, and they're curved. And when you talk, the camera goes over and looks at you, all sorts of things. But fancy teleconferencing, we can do those. We could actually use webcams here. Wouldn't be nearly as spectacular, and you wouldn't want to look at my ugly face anyway. But voice teleconferencing, video teleconferencing, I'm sorry, are things that we're using now. Media nets are ISDN related. ISDN is I guess it's still there. It's kind of the one that didn't work. It has, in the U.S., it has a limitation of around 128K. In Europe, they put them together where you can actually make these things work as a T1 line. The book says media nets are networks implementing technologies that are designed specifically to meet the real-time services challenges are known as media nets. Their designs may be optimized for media transmission over the hardware layers, as an example, the case of ISDN, or by overlapping layer protocols such as SIP or Common Network topology such as IP. So they're unified communications are usually going to use servers, devices, and gateways. They're going to be more specialized, and this is Cisco, I think, first started talking about unified communications, and they have unified communications servers that take care of all of your communications needs from IP phones to video teleconferencing. Presence and telepresence are telepresence is used to refer to sophisticated video conferencing solutions, and I'm reading this from the book. The idea is that the participants have a real sense of being in the same room. That's what these big fancy things are here. And you really do have those things in the telepresence. The concept of presence is central to unified messaging. This is the idea that a user can see at a glance which of their contacts are available. Their current status, busy, away, those sorts of things. What some of you may use on Facebook, are you available? This is really more designed for phones. Is somebody available on the phone system? Can you call them? Are they away? Are they present? Are they busy? Those sorts of things. Multicast versus unicast, we've talked about those. Unicast is one-to-one, machine to machine. Multicast is one-to-many, but you have to subscribe to the multicast. It's optional in IPv4, mandatory in IPv6. Real-time services, we have protocols for those. Session controls, establish, manage, and disestablish the sessions, just like we have in the other ones. They handle the tasks, user discovery, locating the user network, and they take care of availability advertising also. Availability, the data transport, delivery of the actual video or voice information. And if you look at a Wireshark, you're going to see some of these other protocols that work in here at the transport layer. Quality of service ensures that the voice and video are free from problems such as drop packets, delay, and jitter. Delay and jitter are really issues with voice over IP. Jitter is consistency of delay. If you have it changed, that's when you get the calls starting to break up. But the thing that really hurts VoIP is delay. Drop packets obviously can be a problem, but these are really very small packets. If you drop one or two, it's probably not going to affect the conversation that much. If you drop a whole string of them, you're going to have a real issue with them. Session initiation protocol, SIP, is one that the first time I ever saw it was on VoIP phones, but it's used for teleconferencing, and I think that the first time I ever saw it was in a Cisco environment. User discovery, it has user agents, user discovery, peer-to-peer client server, ports 5060, 5061, TCP or UDP. TCP, you may say, hey, yeah, we really like TCP to make these things connection oriented. TCP may not work for these high speed things because you may not be able to wait for the acknowledgement. And if they come out of order, dropping small segments may not affect the stream. But if you try to resend it and put it back in the stream, it could affect what you're doing on the system. Media Gateway Control Protocol, more and more. This is all of our Netflix stuff, right? The Media Gateway Protocol provides similar functionality to SIP, and it's known as a call agent. A number of these things do the same thing, as just how long they've been around, who makes them, and are they proprietary. H23 is an older system, uses terminals and gatekeepers for it. H323 predates SIP and MGCP. And to say here, it was standardized in 1996. The current version was published in 2009, and even one in 2009, in the way things go, are relatively old today. Real-time transport protocol delivers the media packet. It uses UDP to minimize overhead, sequencing, and timestamps. It does a lot of the function that we would expect TCP to do, because this protocol does the sequencing and the timestamping, and do we get everything. The control protocol monitors the session and provides a quality of information, and it checks to be sure that everything is still on track and can modify what goes on to be sure that we get from one to the other. Uses the default port pair RTP 5004, RTCP 5005. These two we're going to use. The pair is going to use the even. The even will go to the RTP, and the odd will go to the control protocol, or the next odd, whichever is available. Quality of service, we got two of them here. I already talked about. Latency, the signal delay measured in milliseconds. It's the real problem. It's a particular problem with voice calls. Jitter is a variation in delay. If it comes, and that's, you can hear those things sometimes. We used to get those in overseas calls. You can hear it change because the voice changes, and it makes the call be not really all that good. Quality of service, traffic streams for prioritization as opposed to standard or best delivery. Actually, was saying quality of service prioritizes traffic. Some of them get more priority than others instead of the best effort. And TCP or UDP actually is the best effort. TCP guarantees delivery, but it sometimes is not fast enough for the things that we're using now. Differentiated services is one of the fields in the layer 2 protocol. It tags traffic at layers 2 and 3. Differentiated service code places a type of service, traffic IP, and so we can map these things to a priority field in the frame header. What we're saying here through all of that nonsense is that we can assign priorities to these things. Resource reservation protocol runs on hosts and routers, and the switches can actually reserve bandwidth on these things. Multi-protocol label switching can label the things, and again, we're talking quality service. Each of these things, we're really talking a quality of service tag that goes on to these things. The MLPS adds a label to the packets passing over the network and tag them for the traffic. So again, we're talking how good can it go. Quality of service versus class of service. Privileged real-time data or bursty data. The class of service tags the data with a priority, and the quality of service allows control over the network link parameters. Different things that they can do there. Packet shapers. It says traffic policing to enforce bandwidth limits, and bandwidth limits can sometimes become an issue. I get a bunch of emails, find your bandwidth hogs, and on all of these things that you can do on the network, and you could probably do that with most of the sniffers. But a traffic shaper itself reserves the bandwidth. It actually prioritizes the traffic. It'll save traffic and send it when the system's not as busy, so that the priority traffic goes out, the other traffic may be delayed, and it can deprioritize unwanted traffic, but it can also hold traffic that has a lower priority and send it later, which can be an advantage. That way your phone calls and your teleconferences go as scheduled, and everything else gets sent. It just may not get sent immediately, because a lot of traffic isn't really time sensitive in the way that we would be time sensitive with phone calls and those sorts of things. Load balancers allow us to balance the load, obviously. If we have higher throughput, what they do is if we had a particularly busy website, perhaps we would put 2 servers up with the same content or 3 servers up with the same content. We put a virtual interface out here with an IP address on it and a MAC address. We kind of talked about this earlier. And then the management will go here, and then this interface will send it to whichever server is not busy at the time. So it's SSL offload, caching, TCP offload. There are different ways to offload these things. Round robin DNS, we would have multiple DNS entries for the same website, and we'll call it website D, and it will go, the DNS server, and these would be the multiple servers out here. The DNS would send it to the first server, the next one would send to the second server, and then to the third server, and then to the fourth server, and then start all over again. You can configure that in DNS. Server load balancing, network load balancing, or clustering is kind of what I was talking about up here. We have a cluster and we have a cluster management. And the cluster is multiple servers with the same content that then get things sent to them one at a time. And that's what the big websites are going to be using. They actually use bigger servers too, but they're going to use things like that. Stateless versus state full fault tolerance. What's the state of anything? Is there a state table in these things? And then layer 3 switching. A layer 3 switch is really a switch that switches in IP addresses rather than that works at layer 2. It has it knows the maps the IP addresses of the switch ports. Excuse me. Much like a switch learns the MAC addresses, it learns the IP addresses, and that's where we get the route once switch many. It gets routed once, and then it gets set into the table, the switching table here for layer 3, and that's going to make it faster as we go through here because it's now working in hardware instead of in software. And we have content switches and work at layer 4 through layer 7, encryption, caching, TCP multiplexing. There's a number of, and they keep coming up with more and more and more of these devices to make the networks faster and faster and faster, and that's what allows us to do the things that we're doing. That's what's going to get us to the Internet of Things. So we looked at web protocols, the functions of communication protocols, the basic elements of quality of service, and the functions of the application packets, shapers, and those sorts of things. So let's look at some of these questions, and then we'll do labs. What must be installed on the server to use HTTPS connections? Certificate. Got to have a certificate, and if you don't have that, it don't work. What TCP application protocol is associated with port 21?
FTP.
Say which?
FTP.
FTP, exactly. Why can FTP operating in active mode, why can FTP operating in active mode be difficult to configure with firewalls? I'll do that one because I talked about it. I'll probably make it real clear. The server has got to be allowed to open an inbound connection, and it doesn't know what the source port is at the other end. Remember, the well-known ports are what you're connecting to. The source ports are random for us. The random ports are ephemeral. You'll see them called ephemeral or random ports. What distinguishes TFTP from FTP?
UDP layer?
Well,
Connectionless.
connectionless, and it's a very simple protocol, and TFTP supports many fewer commands than FTP, although FTP doesn't really have all that many commands. If you want to practice FTP, you can FTP to ftp.microsoft.com. They have an FTP server out there. They'll show you and how to get logged onto it if you want to if you should ever want to play with those things.
And that was again FTP.
Yeah, here, let me see if I can get there. It's FTP ftp.microsoft. I spell Microsoft wrong. Microsoft.com. I did that wrong, didn't I? FTP. So it was FTP. Did I get it going? I didn't do it. FTP. Well, I'll do FTP, and then we'll open ftp.microsoft. I'll probably mess this up. Now it's open. When you log on, it's anonymous. This is anonymous. ANONYMOUS. Anonymous, right? Did I spell that right? And the password is an email address, and you can use any. It doesn't really have to be your email address. I always use something like you@me.com. And now I'm logged in. This thing uses Linux commands. It'll make me a liar. It uses other commands too. It also uses Linux commands. ls for list them. So we use the directory. You can work around in here. They actually have some stuff up here that you may or may not ever want, but it is their FTP server. And if you need help, you just type help. Get command is the way that you download stuff, and the put command is the way you send stuff. It will also, when you go to the location, it will put it in whichever directory you're in on your Windows machine. So if you're looking for those things. But yeah, ftp.microsoft.com is their FTP server. If you want to play with that any. What happens if a message sent via SMTP cannot be delivered?
You get a NDR message after it times out.
Yep. And if it can't be delivered, whether it's delayed, you're right. And the error message will probably tell you why, like the mailbox is full or the email address doesn't exist or things like that. I think is that a good guess? What protocol would enable a client to manage mail subfolders on a remote email server? Which one would connect you directly to the email server? This is not quite a 5059, but we had 3 protocols, right?
IMAP.
Huh? IMAP.
IMAP?
Yep.
I had to look at my notes.
Yeah, IMAP. Well, that's good. What is the function of a UC gateway, Unified Communications Gateway? I'll give you that one because I didn't talk about the PSTN, and I should have. But it provides an interface between the different messaging technologies such as voice over IP and a publicly switched telephone network, sometimes called POTS, plain old telephone system. So it provides the interface between all the technologies. True or false? SIP enables the location of user agents via specially formatted URI. $50-50-90.
URI was something. Well, that's URL.
Yeah, I think that may be what that's supposed to be. I can't see it.
Oh, yeah. There isn't a URI. So that would be false.
Yeah, it's true. SIP does allow you to find the user agents.
Oh, let's see.
And it doesn't matter, especially formatted whatever, but it does allow you to do that. How is jitter mitigated in VoIP applications? How is anything mitigated if you have delay? What happens when you start up Netflix? What's the first thing it does?
Ask for your password.
After that, mine's cached, so I don't have that problem. When it starts doing that little circle running around and around and around, what's it doing?
It's loading.
It's loading. It's actually caching the first part of the whatever you're watching. And when it shuts down, it runs out of cache. You run it. So we're going to buffer the packets. We're going to actually cache them there. And it's buffering is what it's doing. It's downloading a little bit of the movie before it starts, so that it can be smooth if it has those delay problems. And I guess in Netflix, because a lot of people have it, that's one of the things that kind of brings this to life. And if you start getting the delay in jitter, the movie gets weird. It gets stops and starts and those sorts of things. But buffering, storing a little bit of it in advance allows that too. It's the same way with our satellite radio station. If you're using the satellite radio, Sirius, and you drive into a tunnel, it still keeps playing for a little while because the stations are buffered. And then it quits until you get out, and then you got to reconnect to the satellite and all that good stuff. But buffering stores a little bit of it for a short period of time, and that's the same. We do the same thing with VoIP. Buffering stores a little bit before it keeps going with the conversation to take the variations out of the system. How many different traffic classes can be defined by 802.1 QP? And I did not say this, and this is in the book. It says the field is 3 bits, allowing up to 8 values, 248, right? And because it's bits. 7 is reserved for network infrastructure, routing table updates. 6 through 5 for two-way communications, 4 through 1 streaming, and 0 for ordinary best effort delivery. But those are the priorities that can
What's
go.
the answer? That's
Huh?
my answer. How many?
8. 0 through 7.
That was in the book?
Yeah, that one is in the book. I remember reading that. I would hope that in Network Plus they wouldn't get that deep into the weeds. I'd expect that on a Cisco test, but I wouldn't expect that on a CompTIA, but you never know. How does a traffic shaper benefit real-time data applications? What does a traffic shaper do?
Didn't I give priority?
Yep, priority. It can reserve bandwidth. Yes, priorities reserves. Right here, reserve link bandwidth. And prioritize traffic. It does both. So it can make your real-time things better, more, I would say reliable, but more hearable, readable, seeable. What would a typical scenario for implementing what would be a typical scenario for implementing a content switch? This is going to be more load balancing. To use the switch as an interface for a web server farm would be the example. Performs load balancing by connecting clients to different servers depending on the traffic conditions and policies, which ones are not busy at the time, and it maintains a load or monitors the load on each server so that supposedly gives you the one that's least loaded. If you ever look at things like Facebook, I looked up Facebook's IP addresses one time. They've got 4 supernetted networks with 4 bits in the supernet and 1 with 3 bits, I think it was, or maybe 2 bits. I mean, they got a ton of IP addresses, so they got a whole bunch of servers running out there to make it work. What distinguishes a layer 3 switch from a router? Any thoughts?
The one thing is hardware switching, right?
It uses hardware. A router routes in software. A switch switches in hardware. And a layer 3 switch switches in hardware just like a layer 2 switches in hardware. Layer 2 uses the MAC address. Layer 3 uses the IP address. Questions?